In this video, we're going to talk about arrays. Now we have worked with list, we have worked with tuple, and now we know how those things works. So if you want to have a list of values with you, of course you can go with list, or if you want to make it constant, you can go for tuple. Now, why array then? Now in array, we need to have all the values of same type. So we can have the same list with integer, float, and string in one list, but that's not the case with array. So arrays are similar to list, but with one difference, that you need to have all the values of same type. So if you say it's an int array, it should be of int array. If you say it is float array, all the values should be float. There's one advantage here. Arrays in Python, they don't have specific size, they don't have fixed size, which means you can expand, you can shrink it. Example, let's say if you have 5 values, and if you think, hey, we want 10 values, you can expand it. And if you feel, hey, we have 10 values, but we need only 4 values now, we can shrink it. So it is quite flexible to work with. And it offers you certain methods to work with. Example, if you want to add elements, you can use append. If you want to find a particular element, you can use certain methods. In fact, we have a method called index, using which you can get the index number of a particular value. Oh, hold on. We'll do that in the practical video here. Now, basically, when you will be using array. So think about this. Let's say if you have a list of students, right? And then in that, so every student will have a marks. So let's say we have one subject, which is, let's say, Python itself. So it's a language, and you have a subject in your college. And of course, everyone will be having a marks. So if you have 10 students in a class, you need to create 10 different variables like marks 1, marks 2, marks 3. Or let's say if you have 100 students, you need to create 100 variables. Now, instead of doing that, we can create an array, right? Now, how do we do that? So in order to use array, we will be using array. But then the problem is we will not be getting this array by default, right? Okay, so we need to import a module called as array to use this. So how will you do that? You will say import array, right? So this is up to you. So you have to say import array, and in this module array, we have a function called as array. So we have to say array.array. This is how you create an array. I know it's a lot of arrays there. So if you don't want to use this array every time, you can also use array. So you can say import array as ARR. So instead of using array every time, you can say ARR.array. This one way. So again, you can use array.array by importing array, or you can say import array as ARR, which is you're using alias here, and then you can say ARR.array. Now, if you just want to avoid everything, you can simply use, we have done that before, right? So if you want to work with modules, if you want to import modules, you can say from array import. Now you can specify the functions you want to work with, or you can simply specify stars. So star means you want to work with all the functions, right? Now once you have this function array, now let's see how do we get an array. So I want to create array of, we'll not go for marks here, let's go for vals. Now vals is basically values, okay? So it's a short form for values. Now I want to create an array with the name of vals. So you have to say array. Now we have to specify two things. The first thing you have to specify is the type, and the second you have to mention is the values. Now why type? Because in array, all the values should be of same type, right? So if you say, hey, we have int array, you have to mention that it's an int array. If it is a float array, you have to mention that. How will you do that? Okay, if you have to use some keywords, right? Example, we can say int float, but that is not how it works here. So you have to use a type code. Now what it means? Every type will have a unique code, okay? Example, for integer, in fact, in integer as well, we have different types of integers. We have byte, we have long, and we have int. When you work with different languages like C, C++, Java, we have these types there, right? We have byte, we have long, we have int. Same way in here, in Python, we also have int. Now, depending upon, the moment you change the type, it will change the size in the memory. Example, if you want to say, hey, I want a smaller integer, you can say byte, because byte is a small integer. It takes only 1 byte. The other one is normal int, which will take 2 bytes. And then we have long integer, which will take 4 bytes. Now, what if you want to have float values? For that, it will take again 4 bytes. So it is f float, which will take 4 bytes. In fact, double as well. So we have double float, which will give you more memory of 8 bytes. What if you want to go for character? For that, you have to use U, which is Unicode, right? And it takes 2 bytes, okay? Because Unicode need 2 bytes to store data. Okay, that works. Now the question is, what if you want to have unsigned integer? Now what is an unsigned and signed? So let's say if you're going for normal integer, it goes from a negative range to a positive range, right? What if you don't want to store a negative value? In that case, you will be going for a unsigned integer because it starts with 0 and it ends at a particular value. So we will not be considering negative numbers here, right? And you can see in the table we have all the types. So if you want to work with unsigned integer, you have to use capital I. If you want to use signed integer, which is long one, you can use small l, right? So you can refer this table and we'll be using that here. So I want to create an array of integers, and the way you can do that is by saying I, because you are using an integer array, and you can give a comma, and you have to mention a square bracket because that's how you represent arrays. Now in this square bracket, you can mention values. I will go for simple values here just to make it simple. So I will say 5, 9, 8, 4, and 2. Simple values, we got 5 values here. And once you've got this array, you can print it. And how do we print it? It's very easy. You will say print, and you will print the values here, we'll say vals. Now if I run this code, you can see we got an array. It's so simple, right? You can see it is printing array of type int, and then we got the values. Okay, now let me just do a twist here. What if I put a different value? Example here, instead of having 8, let me say 8.5. Now you can see this is where problem starts. And if I run this code, you can see we got an error. Error says integer argument expected got float. Can you see that here? So this is the problem we have, right? When you say I, it is integers, and if you're trying to put float there, it will not work. So of course you have to go for integers. Can I have negative values? Of course we can have, because small I means signed integer, which starts with negative value to positive value, so it will work. Let me just run this code. So it works, you can have negative values. But what if I say capital I, which means you cannot have negative values now? And the moment you run this code, you can see we got an error. It says cannot convert negative value to unsigned int, right? So this is important to remember. So when you create an array, you have to make sure that you specify a proper type code, okay? Now, once we have done with that, in array, as we are working with arrays now, we can use certain functions. Example, if I say values dot. So one of my favorite function is buffer info. Now buffer info will give you the size of the array, right? So if I say, okay, we were supposed to change this I, small I, so let me run this code, and you can see we got something. Now what is this something? So this is a tuple here with two things. The first one is the address. So this is the address of your array, and the second parameter there is actually your size, which is 5, right? If I change the number of elements here, if I remove 2, of course you will be getting 4 values now, so it will be 4, right? So that's how you can work with buffer info. In fact, we have some other methods as well. I would say values dot. In fact, we also have type code, which will print the type of the code you're working with, which is int in this case. So you can see it is I, which is integer. This was the property here. Now, what if you want to add a value? You can use append. What if you want to remove a value? You can use remove. If you want to reverse the entire array, you can do that here. Example, let's try. So if I say reverse, and if I print the values, and if I say F10, because reverse doesn't return value. So if you want to work with reverse, you have to say vals dot reverse, and you can see first you got the array, it will reverse the array, it will give you the value. So if I say shift F10, you got the value, which is array and then 2, 4. So you can see all the values got reversed. Now the point is, what if I don't want to print all the values as it is? I want to print the values one by one. Is it possible? Of course, right? This is array, and when you say array, it is similar to list, so we can use index numbers, right? Index number start with 0, right? So we can use index number to print one value. So I would say values of, and I want to say 0. Now when I say values of 0, it will print the first value, right? In this case, it is 2, okay? Why 2? Because we are reversing it, right? Because after reversing, 2 will come first. Let's remove that, and because I don't want to reverse now, let's say run, and you can see we got 5. If you change this value to let's say 1, it will print 9. But I want to print all the values, not just 1 or 2 values, right? In this case, we will be using a loop. Your favorite loop. You can work with while loop, you can work with for loop, your wish, okay? Here I will go for loop because for loop makes sense when you know the range. So I will say for I in, where in. In fact, I will be using range. I will start with range will go till 4 or 5 because we have 5 values, right? So range will start with 0, it will end at 4. And every time this loop runs, I have to say I. Now there are 2 things which are missing in this loop. The first one is the colon, right? And the second thing is this print belongs to a for loop. So you have to give a tab, a proper indentation. right? And now let's run this code, and we got the value which is 5, 9, minus 8, 4, and 2. So it's so simple. So this is how you print all these values here. So this is fun, right? So you can print all the values one by one. In fact, we have one more way. So if you don't, so what is happening here is the value of I is changing from 0 to 4. Every time you run this code, it will say values of 0, values of 1, values of 2. But what if you don't know this length of it? Because here we know it's 5. You can see that, right? What if you don't know the length, or if you want to make it more dynamic? In that case, you can say length of vals. So length of vals will give you the length, and you can pass that length in range, right? So indirectly, at runtime, it will be range 5, right? Because the size is 5, and it works. Now this is another way of printing. Or what you can do is, instead of saying range, you can directly say vals. So I will say for E, even I works, but then I will say for E in val, and I can directly print the value of E. So for is very dynamic, So sometimes you can use for with range, which will go for index values, or here it will directly go for the values. So in vals we have 5, 9, minus 8, 4, and 2. So it will fetch the value one by one. So E will refer to 5, then E will refer to 9, then E will refer to minus 8. So your choice, the way you want to work with it. Example, if I run this code, it still works. Okay, so this thing is working. Now can I work with characters? Because we have seen how to work with integers. We can also use float here. Can I work with characters? Of course you can. So what you do is, instead of saying I, you have to say U, which is Unicode. You can say characters. And here, instead of having numbers, we should be using characters. I will say single quote A, single quote E, and then single quote I. So we have AEI, and then if I run this code, you can see we got the same values. So yes, you can work with Unicodes as well. Okay, this thing works. Now what I will do is I will just undo it, and I will go back to integers because I want to do one small operation. Okay, so what I want is I want to create a new array, okay, with the same values. Example, I will just take positive values now, 5, 9, 8, 4, 2. I want to create a new array with the same values. Is it possible? Of course you can do it, right? You can say a new array here. I will say new array, and equal to, you can say the same thing. You can say array and then I, then comma, you can put the same values. But instead of doing that, what you can do is you can say array bracket, and in this bracket you can mention, hey, I don't know the type. See, when you know the type is I, you can do it here. When you know the values, you can type it here. But sometimes you want to copy it, right? Maybe you're getting these values from somewhere else. In that case, you cannot simply type the values, right? So in that case, you can say, I don't know the type, just take the type from vals. Instead of saying I, you're simply saying type code from val, and then the values. Now, I don't know the values, so you can say, now we have a different syntax here, try to understand this. So what we are saying is, hey, I don't know the values, but take the values from vals. So take the values A. Now A will represent one value at a time. A for A in vals. So what will happen now is it will, so this for loop will take one value from vals, and it will assign to the array. So it will say, hey, I got 5 assigned, I got 9 assigned. So that value which is getting up is coming into A, and then it is getting assigned to the new array. Just to prove my point, I will, instead of printing the vals, I will print a new array here. Let's run this code, and you can see we got the values. So the old array values are coming into new array. So syntax is, first of all, you have to mention, hey, I don't know the type of it, get the type from the old array, which is vals. And then the second one we are mentioning here is the loop. So we are saying, hey, I don't know the values. What you can do is take one value from vals, and you can do that with the help of for loop, right? So you're saying for A in vals, and then it will fetch one value, you're assigning it to the array. It works. In fact, you can do one more thing. Instead of assigning the same value, what if you want to assign the square of it? Example, I want to assign 25, 81, and so on. I want to assign the square of a number. In that case, you can simply say A into A. So you're simply creating a square of a number. Let's run this code, and you can see we got values. We got 25, 81, 64, 16, and 4. So we are getting the square of a number. So it's so simple to do all this stuff in Python, If you want to do the same thing in other languages, you have to write multiple lines of code. And that's why we say, in Python, you can do multiple things in less number of lines. Now, what if you want to print these values using while loop? Again, we have done with for, so we know how it works. Can we use while loop here? Of course we can. A lot of people have this confusion with for and while. You can use while loop here as well. Now, but the thing is, for while loop, you have to use 3 steps, right? You have to use initialization, you have to check for the condition, and you have to do increment, decrement by yourself. So let's do that. So I will say I is equal to 0. If we have to check for the condition, so we'll say while I less than length of new array, because I don't know the length of new array, colon, and then here you will say print the value, print new array, and then we have to use index value, so we have to say new array I, and once you have printed it, you have to do increment or decrement, because here we have to use increment, so I will say I plus equal to 1. So the thing is, you can do it, but the only thing is you have to do it manually, and you can see it works. And I know in this case, for loop makes more sense, right? Because you don't have to initialize, you don't have to increment, decrement, and you don't even have to check for the conditions, right? But you can use while loop. So now there are more to arrays. In fact, we have so many things to work with arrays now. So in this video, we have talked about the basics of array, how can we create an array, and how can you print the values, how can you create a different array from the existing array. Now till this point, we have seen some basics on Python and we have talked about array as well. But we want to do one more example here. So the previous assignment was about taking the values from the user, and that's where the problem starts, right? How can you create an array where the values will be coming from the user? Because when you say your values will be coming from the user, you don't know the size of the array. So if you don't know the size of the array, how can you create the array, right? So in this example, we'll do that. So we'll create an array, a blank array, and then we will ask a user to enter the values, and at the end we'll ask a user, hey, you want to search the element? And if a user says, okay, I want to search for the element, and then let's say if a user says, hey, I want to search for number 5 and tell me the index value of it, we'll be doing that example here. What I'm going to do here is very simple. We want to create an array, and we want to take the values from the user. So step 1, we need to create an array, right? So I would say ARR is equal to. Now this ARR, I want it to be a blank array. And the way you do that is by saying array, and then of course, right, when you work with array, you need to mention the type of the values, right? So you will say I, and you will give a comma here, and then you have to mention the array values. But then we want empty array, right? So we'll give a square bracket. So this is how you create an empty array. Now we have one small issue. We are using array, but we forgot to import the array module. So we'll say import, not import, we'll say from array import. I want to import everything, so I will say star, right? So I want all the classes, all the functions, all the variables, we'll say star. Now once you got the array, I want to add the elements. So when you say you want to add the elements, you will be asking users to enter value repeatedly, right? So when you say, we'll say, hey user, enter next value, enter next value, enter next value. But how many times do we have to say that? So before asking for the values, we will ask for the length of the array. So we'll say, hey user, how many values you need? So user says, hey, I want to insert 5 values. Let's do that. So we'll say n, and in this I want to ask for the length of the array. Okay, so user will enter the value. We have to use input function, but input will give you string, so we will convert that into integer. So we'll say int, and here we'll say input, and in this bracket you have to mention the message, right? So I would say enter the length of the array, right? Now once you got the length, now the next step is I want to ask a user, hey user, enter the value you want to insert. But then I want to do that repeatedly, right? So if a user says, hey, I want to insert 5 values, I have to ask for the element 5 times. Now of course, when you say you want to do something repeatedly, you have to use a for loop, right? Of course, while loop will do here, but I will use a for loop, and I will use a variable I in. Now when you say you want to go for 5 times, the best way is to go for range, and the range would be 5. We'll give a colon and enter. Now every time this loop runs, I want to ask a user to enter the value, and I will put that value in a variable x, right? So I would say x equal to, the way you can ask a value is very simple. Again, the same thing, you need to use this function. I will just copy and paste it here. Now instead of saying enter the length of the array, we will change the message and we'll say enter the value, right? Or we can say enter the next value. This makes sense, right? So every time a user enters the value, that will go into x, and the same value x will go into array now. And the way you do that is by saying arr dot. How do we add values in the array? So for that we have a function called as append, right? So we'll use append here, and every time you want to add the element, just pass x and your job is done. So your loop iterates and you will put the element in the array. Now how will you verify this? So we'll go at the end, and here we'll print the values of array. So we can directly print it. We can say print array. So this is one way. You can directly print the array, or you can use a for loop, right? Your choice. I will just run this code. I hope it will work. Okay, let me just verify. If I say shift F10, you can see it is asking for the length. I would say, okay, I want to insert 4 values. Okay, now it is asking for the next value. So I would say this is 16. The next value is, let's say, 20, and then we got 48, we got 21, and we got, let's say, 10. So these are my 4 values, right? Oh, it is going 5 times. That's bad. We said 4, right? Why it's going 5 times? Because I made a small mistake. You know, we ignore something. My bad. Instead of saying range 5, I should have said n, right? Because we are asking for the length. My bad. Okay, let's do that again. Asking for the length. I will say 4, enter the value 16, 20, 14, 52. You can see I've entered 4 values. The moment I say enter, we got 4 values, right? So that's your array, and that's how you can take the info from the user. So every time a user enters a value, you just have to append it to the array. Okay, this works. Now what I'm going to do is I want to ask a user to enter a value, and then we will search for the index. Example, if a user says value 14, then we need to print the index number of it, which is in this case 2, right? Now there are 2 ways of doing this. One, manually, and second, by using some inbuilt functions. Now, what do you think? We should be going for manual first, right? So we'll do it manually first, and then we'll see which function we can use to fetch it. So how will you do it manually? Now, when you say you want to get the index number, what you have to do is, let's say if a user says value 14, so you have to check, you need to compare. Is 14 is same as the first value of array? If it is same, you got the index number. If it is not same, shift. Just check for the second value. Is it matching? No, then shift. I mean, next one, which is 14 and 14 matching? Yes. So you got the answer, right? So every time you run through the loop, you have to increment the value, right? And that will be your index number. So what I'm saying is, just take a for loop. In fact, first of all, we have to ask a user to enter a value, right? So we'll say a value val itself, and we'll ask a user to enter the value. So I will use the same, I would say, enter the value for search. Right, this is what we will be asking the user. The moment a user enters a value, that will go into value. Now we will run a loop. We'll say I in array. The moment you iterate this loop, you will check if I is equal to the value which you have. Now say this I is, the value of this I is coming from a range, right? So the range would be 0, 1, 2, 3, 4. But this I here is not coming from the range. The value is coming from the array itself. I know we have the same name, so we'll say E. Okay, instead of saying I, will say E, because this is how we represent, right? So I, we can take it as an iterator or the counter variable, and we will, let's say, E is an element, right? So value of E will be coming from the array itself, one element. So we are comparing if this E is matching with the val. In case if it is matching, we will print the index number, right? So, how do we know the index number here? That's a confusion, right? Now to maintain the index number, we will use a counter variable. We'll say k. The initial value of k would be 0, right? So k will start with 0. And every time this loop iterates, we will increment the value of k. So we'll say k plus is equal to 1, right? So we are incrementing it. But what if it is matching? In that case, you will print the value of k. That's it. So if it is matching, we'll simply say break, because we don't want to search ahead, right? If this is matching, that's it. That's the end. So we'll say break. Now I hope it will work. Let's verify. I would say, okay, so what is happening once again is you are using a loop, and the value of E will be coming from the array itself. Now if that E is matching with the value which our user inserted, you will print the index number, right, which is k in this case, and you will say break. Let's run this code, and you can see it is asking for the length again. I will say 4, and I will enter the value, which is 14, 52, 98, 36, and you can see we have entered 4 values, and that's your array there. Now it is asking you for the value which you want to search for. I want to search, let's say, 52. The moment I say enter, you can see it says 1, because that's the index number for 52, right? So this is how you can work with it. Right? It's very simple. You can try it out. What I would suggest you is, after watching this video, don't practice directly by watching the video. After finishing watching the video, okay, you can pause it and try it by yourself. Don't look at the code, because when you look at the code, you feel it's just simple. But when you try it by yourself, that's where the problem starts, right? So try it out. Let me know in the comment section how it is going. So that's how you insert the value in the array. That's how you search for it. Oh, we are missing one more thing, right? How will you use functions here? My bad. If you want to use function, you don't have to do anything like this. You simply say print, and in this print, you will use an array, and you will say a method called as index, and just pass the value, which is val. You know, you don't have to do anything else. You don't have to use this loop stuff. You can simply say, hey, we have an array of 5. Let's insert the values. Some big values this time. Okay, so you can see I've inserted these values, and now it is asking you for the value which you want to search. I want to search for 587, right, which is index number 3. The moment I say enter, you can see we got 3 and 3. So we got the first 3 because of the loop, we got second 3 because of this method, because of this function. Now that's the advantage, so when you work with Python, we got so many functions to work with and it saves your time. But knowing how to search manually, it will be helpful if you want to create your own algorithm in future. Now till this point we have worked on arrays and we are happy, because we know how to work with array, we know how to insert values, we know how to fetch a value. But here's the thing, when we talk about arrays, we have different types of arrays available. Example, the first one is single dimensional array and second one is multi-dimensional array. Now when you say single dimensional, it means you have a one row. Right, so you have one row and multiple columns. Example, the array which we are working with, so it has one row and multiple columns, right? You can see we have multiple columns there. But what if you want to work with multi-dimensional array, which simply means you will be having multiple rows and multiple columns? When I say multi-dimensional, it can be 2D, which is 2-dimensional, it can be 3-dimensional, it can be 4-dimensional, right? So it can have multiple dimensions here. Now the way you can represent that is something in this way. So when you say single dimensional array, this is how it looks like. When you say multi-dimensional, you can imagine this is 2D array, which is 2-dimensional array. Or you can imagine 3D, which is you can imagine as a cube format, right? Now when you say 2-dimensional array, you can use it for using, let's say, metrics. So let's say if you are working on some scientific calculation, you have metrics there, you can use 2D array, right? So it is so useful, right, working with multi-dimensional array. So can we do it in Python? Of course we can, right? So it's one of the best language. But here's the thing. If we talk about the array which is available in Python for you, in that you cannot work with multi-dimensional array, unfortunately. Because even if you try for that, example, if I create an array, so let me just remove this code from here. Okay, so I'm using array here, right? And if I want to create an array which is multi-dimensional, I would say arr is equal to array, and the type of the array will say I, and we want to assign multi-dimensional, right? So the way you do that is by giving multiple square, because if you say one square, that's one row. If you want to have multiple rows, you have to give two square bracket. In each square bracket will have a value. So we'll say 1, 2, 3, and then we got another array which is 2, 4, 5, 4. So we got two arrays here. So when you combine them, it becomes multi-dimensional array, right? And if I try to print this array here, you can say this will not work. So you can see we got an error here. Okay, so how do we work with multidimensional? Because in array we don't have that. So the package which we are using here, which is array, does not support multidimensional, and that's where we can use a third-party package, and that is your Numpy. Some people say Numpy, it doesn't matter. So we have a package called Numpy, and we have to use that. So we can simply say Numpy, instead of fetching from array package, we will use a Numpy package. Okay, and in Numpy also we can create array. Oh, but we are getting error here. You can see if I go back here, it says unresolved reference Numpy. Spelling mistake? No, it's perfect. What if I say by default Numpy package is not available in Python? You have to install it. You have to install it manually. Okay, but before doing this, let me just go to IDLE. So this is my IDLE, and here I want to use that package. Let's try. So I would say import Numpy, and you can see we got an error. It says Numpy is not a model which is installed. So it says no model name Numpy. So we need to install it. How will you install this? So in Python, we got this amazing tool called as PIP. So you have to use PIP. In fact, PIP3 here. PIP basically stands for, it's a recursive full form, which is PIP install packages. Okay, so if you want to install any other packages, in fact, we have a lot of packages available, and if you want to install them, we have to use PIP. So I will go to my command prompt, and here I will say PIP3, okay, the version 3, and you need to install Numpy. So you have to say install Numpy. Okay, that's it. Simple command, and say enter. It will take some time. Okay, so we'll wait for some time to install it. Okay, you can see it says Numpy successfully installed, because see, I'm doing this for the second time. I already had a Numpy. I removed it so that I can type the code here. But then if you install Numpy for the first time, I guess it will also ask you for the agreement or confirmation. You can simply say yes there. And you can see in this system now we have Numpy. I will just restart my IDL, and I will again type the same things. I will say import Numpy, and you can see there is no errors. That means we have Numpy in the system now. But then it is for IDL, right? How about Pycharm? So if you want to work with Pycharm with Numpy, you need to install Numpy here as well, because you can see we are still getting error here. So how do we install Numpy in your Pycharm? To do that, we need to use a shortcut for Windows, which is Control Alt S, which is simply going to settings. So we'll say File, Settings, and here you need to make sure that you click on Project Test Project or Project and your project colon your project name. Click on Project Interpreter. Here you need to install Numpy, right? So what you will do is you will click on this plus symbol, and here you have to search for Numpy. So we got Numpy here, click on install. It's so simple, right? You just say next, everything is done. So it is installing, it will take some time. It also depends upon your internet speed, your system speed, so it will take some time. And you can see it is installed. Now click on close. Okay, so you can see we got Numpy here. This one, which is latest version, is 1.15, so that's great. We got the latest version. So Numpy is installed, but it is not referring. Oh, it's working. You can see we got from Numpy import star, and I think it should work. But there's one change here. When you work with Numpy, first of all, let's work with normal array. Okay, it's not that when you have Numpy you cannot work with single dimensional array. We can. I will just remove this two-dimensional array here. Let's work with one-dimensional array just to verify it is working. I will say Shift F10. Oh, we got an error. Because in Numpy, we just need to change the way it works. You don't have to actually mention the type here, okay? It is optional. You can skip the type, and you can see if you say F10, it works, right? So this is how you work with Numpy. Again, we'll use Numpy to work with single-dimensional, multi-dimensional, and we'll do some operations as well. But at this point, now we know why we need Numpy, now we know how to install Numpy, and now we know how to create a simple array using Numpy. And yes, you can still mention the type if you want to. Example, if you want to mention this is int, at the end, just give a comma and say int, okay? So we need to do that as well. I mean, we can do that as well. So let's run this code. Okay, so it still works. So that's how you use Numpy. So in the subsequent videos, we'll work more on Numpy. Now till this point, we have seen how do we work with arrays, and then we realize if you want to work with multi-dimensional array, or if you want to perform some scientific calculations with array, we have a special package called as Numpy. And you need to install them. So we can install on command prompt, or we can install them in the IDE itself. So in this video, we'll see what are the different ways of creating an array in Numpy. So we'll start with it. Now basically we have 6 ways you can create an array. The first way is array itself, the function array. The second one is line space. Then we have log space, arrange, zeros, ones. So basically we have these 6 ways. And we have seen the first way, right? But let's redo it again. So what I will do here is I will create an array, and before using an array, we have to import them, right? So we'll say import Numpy. In fact, from Numpy import start. That's how you import, right? Now, once you got this, once you have said import, now let's create an array. So I will say arr is equal to array, and in this you need to mention the values you want to put. So I will say 1, 2, 3, 4, 5. So we got these 5 elements, right? Now, if you remember, in normal array package, we need to specify the type as well, right? But here we don't need to do that. We can specify the type, but then by default, it will guess the type of values you're entering, and based on that, it will convert. And if I say I want to print the value, so you can simply print the value. I would say print, and here I will print A. So ARR, the array. The moment I run this code, you can see we got the output, which is very simple: 1, 2, 3, 4, 5. We can also check for the type of it, what type of values we are going for. So if I say D type, and if I run this code, you can see it says int 32. So by default, it will check for the type of values you have. Since it is integer, it will say, okay, integer means I will take, so all the integers I will take int 32. But what if I specify some weird value? So if I say 5.0, now what will happen? So if you look at this code, we have integers and we have float together. Now if you remember the concept of array, all the elements should be of same type. So now you guess what will happen. All the values will have the same value possible, right? So let's try. So if I run this code, you can see it is float. So what happens now is all the values here, they have been converted into float. Example, if I print the array here, so if I say print ARR, and if I run this code, you can see all the values. Look at the values there. It is 1 point, 2 point, 3 point, 4 point, and 5 point. So every value here is converted into float. So that's the thing. So of course, all the values should be of same type. So we have to do conversion. Now, since you are not doing it explicitly, that's where your implicit conversions comes into picture. So your Python says, hey, I can see one float there. I will convert it into float format, all the values. Now you can also specify the type of element you're working with. So you can give a comma and you can say, hey, this is int. So all the values I want to be int. So you can see we got int32 and then we got the values. What happens if you have the values which is int, but then you're saying float? If I run this code, you can see we got the output, there is no error, but we also got float 64 and look at the values. So when you say float, even if you insert integers, it will convert them into float. So this is how you create an array in Numpy. Now, once we know this, so this is one way, right? This is one way of creating an array. The another way of creating an array is using a different function called as linspace. So what I will do is I will type the same element. And in fact, let me just do that with the help of linspace. I will not be using this d type anymore. So I will be using linspace. So I would say linspace. Again, this function is coming from Numpy itself. So I would say linspace. Linspace will take 3 parameters. So you can see it says start, stop, and you have to also specify the step. Now what it means, example, if I say 0 and if I give comma 16, now you can see I'm not specifying the third one, which is steps. So if I run this code with this, so any guess what we'll get? Okay, in fact, I will type the third element and then we'll try. So if I say 10, normally what happens in normal, if you remember, we have range in list, right? Or we can use range as well. Now, if you use range, it also takes 3 parameters. The first one is start, stop. Now, the stop in range is excluded, but in this case, the 16 here is included. And then this 10 is not the step here. This 10 is basically means the number of paths you want to go for. So if I say 16 here, so what it will do is it will take this value from 0 to 16. In fact, I will go for 0 to 15. So 0 to 15, the number of values is 16, right? So it will break those values. So it will break the range into 16 different parts, right? So if I run this code, you can see the output. So you're getting the values from 0 to 15. Now you might be thinking, why dot here? Because all the values here, they are float. Why float? Because you are breaking the range into parts, right? So the range is getting divided into 16 parts. And normally when you divide into parts, you might get a float value. Okay, this is awesome. So when you say 16 and this thing is perfectly works, but what if I go for 20 parts? So now this range, which is from 0 to 15, will be divided into 20 parts. So if I run this code, you can see you got 20 parts and you also got some float values, right? So this is how you use line space. Now, what if I don't specify the third element? If I only say first and last one, in this case, it will create 50 parts because that is by default. So if you don't specify the parts, the number of parts, it will be 50. And you can see we got 50 parts here. So that's line space. The next one we have is a range. Now, it's not a range, it is a range, okay? So even I got confused when I was doing this for the first time. So it is a range, you can say, a range, yeah. Now in this a range, so it is same as range. So in this case, you have to mention the first element, you have to mention the last element, and then you have to also mention the steps, okay? Now this is not the number of parts, it is steps. So if I say 2, now in linspace, it will create 2 parts, right? But here, it will not create 2 parts, it is its steps. So it will print 1, then it will skip 2 numbers, and it will print 3. Okay, let me just do that. So if I run, you can see we got the values here 1, 3, 5, 7, 9, 11, and 13. So this is what you got. So again, as I mentioned, there are different ways of doing this, right? So this is one of the way. Another way of creating an array is using a concept called as log space. Now log space is different from linspace. The difference is in log space, I mean, of course, linspace and log space, you have this, you create parts, okay? You break down the range into number of parts. But in linspace, the gap between 2 elements is fixed, right? Example, if you take any 2 elements, constituent elements, the gap between those 2 elements will be same. But that's not the case with log space. In log space, if you mention data like 1, 40, let's say 5. Now the difference between the number of parts would be 5. So the spacing between 2 numbers would be depend upon the log of it. Okay. So it will start from, so this will start from 10 raised to 1. So 10 raised to 1 to 10 raised to 40, and it will get divided into 5 parts. Let me just do that. So if I say run, you can see we got 10 raised to 1. The last number is 10 raised to 40, and all the numbers are in between. So if I print the first element here with a specific syntax, I don't want to print E here. I want to print in normal format with first only the after point. I want to just print 2 digits. So you can do that with the help of percentage. In single quote, you have to say percentage dot 2f, again a percentage. So if I run this code, you can see this is the first one. So 0 is the first one, this tends to 1. And if I say the last one, which is 5 parts, right? So it will be 4. And if I run this code, you can see the last one is, now we have to count, okay? So it should be somewhere around 40. So this is how it works. This is how you use log space. So all the values, the difference between different values is of log. So look at the values. So those are differentiated with the help of log of the log value, okay? So that's about log space. So till this point, we have seen 4 functions: array, linspace, range, and log space. Now we have 2 more. Now these 2 more are actually very efficient. The first one is zeros and the second one is ones. And you can guess it, right? So if you want to create an array, let's say of size 10, and all the values by default should be 0. In that case, you will be using zeros as a function. So I'll be using zeros. And in these zeros, we have to specify the size of it. Example, if I say 5, it will create an array of size 5 with all the numbers as zeros, right? In other case, we can also use ones. The difference is zeros will give you zeros, ones will give you 1, right? It's so simple. But if you can see the output, we are getting 1 point, right? Which means you are getting float values. That's the same case with 0 point, right? So when you say zeros, it will give you 0 point. What if I want to mention, hey, I want to work with integer? In that case, you have to say 5, int. Now you are mentioning, hey, I want to work with integers, so please give me integers. If I run this code, you can see we got all the ones, but in integer format. Till this point, we have talked about arrays and Numpy, and we know how to create arrays in Numpy using different methods, right? Now in this video, we'll do some more operations on array using Numpy. Not just that, we'll also use a concept, or we'll also work on a concept called as copying an array. How can you create another array from the existing array? So before going for copying, let's do some operations here. The first one is, what if you have an array here? Let me just create an array for you. So let's imagine we have this small array here, which has 5 values. What I want to do is, I want to add this array with the value 5. So whatever values we have here, example, we have 1, 2, 3, 4, 5, right? So I want to add 5 to each element. Now, there's one way you can do that if you want to do it manually. So you can use a loop, right? Iterate the loop and just add the value 5 to each and every element, right? You can do it. In fact, that will be your assignment, okay? So just try it out. I will not be using any for loop here. What I will be doing here is I will use a simple operation. So I will say ARR is equal to ARR plus 5. That's it. The moment you do this, it will make sure that it will add the value 5 to each element. You don't trust me? Let's try it out. So I will say print ARR. And let's run this code. I hope it will work. And can you see that we got values which is 6, 7, 8, 9, and 10, right? So we are adding 5 to each element. So it's so simple when you work with arrays here. In fact, not just this, you can add 2 different arrays. Let's say we have, this one is one array now. I will name this as array 1. And then we got another array, and this one I will have different values, of course. I will say 6. So 6, 1, 9, 3, and 2. So these are my values, right? What I want to do is I want to add these 2 arrays. Is it possible? Of course it should be, right? I will say this is array 3, and this one is array 1 plus array 2. So if you want to add 2 arrays, it is very simple. Just need to say array 1 plus array 2. So what will happen is it will add add 2 arrays, but with each element. So when you say 1 plus 6 will be 7, then 2 plus 1 will be 3, right? So it will give you that output. So let's run this. Let's see what happens. And you can see we got 7, 3, 12, 7, and 7. So that's how you add all the values here. So it is so easy to add 2 arrays as well. Now this is also called as vectorized operation. Okay, so that's how you add 2 arrays. So what else we can do? If we talk about mathematics, right? So since Numpy stands for num, right, which is numerical, so of course you can perform certain mathematical operations, right? Example, we have trigonometry operations, which is sine, cos, and tan. Can you do it here? What if you want to find the sum of the array? Let's try. So imagine if we have the first array here. Let's remove the second array. And with the first array, I want to perform certain operations. So you can find the sign of the array. So you can say sign, and you can simply pass an array there. And if you run this code, so that's how you can find a sign value for each element there. You can do the same thing for cos. Instead of having sine there, we can say cos, and of course you will get the value. How about finding a log of it? It's very simple. Just replace the function name, right? So, it provides us so many functions to work with. We have sine, we have cos, we have log. In fact, we can also find square root, but let me just run this code first. And you can see we got the log values for the existing values here. How about square root? So I will say sqrt and just run this. And it works. You can see the square root of these numbers. For 4, the square root is 2, and you can see that we got the exact value here. For 1, the square root is 1 itself. So, and for other values, we got the square root as well. So yes, this thing works. In fact, you can find the sum of an array. So you can simply say sum, and the moment you run this code, you can see we got the addition of the entire array, which is 15 in this case. You can also find the min value. So you can say min and run this code. Okay, you can see 1 is the min value. You can also do max, which is the maximum, which is 5. Right, so that's how you can find min value, max value. In fact, you can find the unique element, and you can also sort this array. Now, luckily we have the array sorted here, but you can sort the array if the values are not in ascending order, right? So you can do all those operations. We have a function like unique, you have a function called a sort. So I would request you to do all those stuff by yourself, okay? So just try it out. The more you try, the more you learn, right? In fact, if you want to concatenate 2 arrays, you can do that as well. Example, we were having this earlier array, right? So let me undo this operations here. So you can see we had this 2 array, and I want to concatenate those two arrays here, which is very simple. Just need to use a function called as concatenate, and here you have to pass 2 arrays, ARR1, ARR2. That's it. You just need to use this function, and you can see we got the big array with all those values, right? So that's how you can perform certain operations. So after doing all this stuff, let's talk about the serious stuff, right? The main topic of this video, which is how do you copy an array? It could be very simple, right? So if you have an array here, let's say we have ARR1. So let's say we have this array, and now I want to create another array, okay, by copying this. It's very simple actually. You can simply say ARR2 is equal to ARR1. Simple, right? And then if you print both of these numbers, I would say ARR1. And I want to print the second array as well. Now, what do you think? Will you get the output? That's the first question, right? Will you get the same values? That's a different question. So first, let's find out will it work. And yes, the answer is yes, it will work. What about the values? In fact, the values will also be same. So if you run this code, you can see we got the same values, right? So that perfectly works. But then what happens is, so what do you think? Do you really have 2 arrays in your memory? Not exactly. In your memory, you still have 1 array, okay? Now, how do I know that? If I print the address, remember we have worked with ID before. If I try to print the address of ARR1 and if I try to print the address of ARR2, now look at the values. Okay, I'm not printing it, my bad. So I've added the print statements, and let's run this code, and you can see the address there. Both the arrays has the same ID, which means even if you have 2 different variables, we still have 1 array. That means both are pointing to the same array, right, or same memory address. Now this is also called as aliasing, because you are creating a new alias for the same array, right? So you can modify the values using ARR1, or you can modify the values with the help of ARR2, right? Your choice. Okay, this is fun. Now what if you really want to create 2 different arrays? I don't want to have same array. I want to create different arrays. How will you do that? So I want to create one array which will take different address, second array will take different address. The answer is simple. Instead of saying ARR2 is equal to AR1, you will say ARR1 dot view. Now view is a function which will help you to create a new array, okay, at a different location. Now how do I know this? Let's run this. Let's see what happens. So if I run this code, look at the address. Of course, you'll be having the same values because we are copying it, right? But look at the value. Look at the address. The address is different. That means we have 2 different variables with 2 different address locations, right? Okay, this is fun. But there is one little problem here. The copy which we are doing here, in fact, when you talk about copy, we have 2 different types of copying, okay? One is shallow copy and second is deep copy. I know, name is confusing, but let's get started. So when you say shallow copy, it simply means it will copy the elements, but then both the array are still dependent on each other. What I mean by that is, if I change the value of at least one element here. So before printing, of course, I will say ARR1. I want to change the second element, so I would say A of 1. ARR1 of 1 is equal to, let's say, 7. So I'm changing that value 6 to 7. Now what do you think? What is the output? Of course, when you print ARR1, it will print 278, right? And what about ARR2? Now, since we are not changing the value of ARR2, it should be 268, right? But unfortunately, since we are doing shallow copy, you can see the values are changing for both. It's not just changing for ARR1, it's changing for ARR2 as well. And that is something which we don't want. So this is shallow copy. Okay, now how do we achieve deep copy? Now, when you say deep copy, it simply means, so there are two different arrays and they're not linked with each other in any way. Right? So instead of using a function called as view, we will be using a function called as copy. So copy will give you a deep copy, right? So if I run this code, look at the output now. Of course, they got two different addresses, as you can see here, and look at the values as well. So the changes has been reflected only in the first array, not in second array, right? So that's how you basically copy an array. It's very simple. So basically we have three ways. One, you can say ARR2 is equal to ARR1, your job is done, but that will be simply aliasing because you still have one array. The second way is using view. In view, you use a shallow copy, right? And in deep copy, you just have to say dot copy and it will copy. So it will create two different arrays and two different values that are not linked with each other. Now till this point we have talked about NumPy, right? But there is still one question. We have talked about NumPy 3 to 4 videos before, and then the reason we started with NumPy is by talking about multi-dimensional array. And till this point, we have not touched it, you know. So that's the awesome thing about NumPy. Other than multi-dimensional array, we have so many features, right? But in this video, finally, we are talking about multi-dimensional array. Now, what is multi-dimensional? So we have seen the theory, right? We have one-dimensional, we have two-dimensional, we can create three-dimensional. Now, with that, I want to perform certain operations, right? So in this video, we'll talk about two-dimensional and what operations you can perform here. Okay, so let's create a two-dimensional array. Okay, so we got an array, and then since with the moment you say you want to create multi-dimensional array, you need to use this symbol, right? So this is one array. So this is one big array which you have, and inside this one big array, you want two different arrays. And that's the idea, right? If you have one array with multiple elements, that's one array. If you have a big array, inside that array you have arrays itself, that is multi-dimensional or two-dimensional array, right? So this is one big array, right? And in this one big array, you have two more arrays. So you will say we have two more arrays, and each array will have certain values. I would say 1, 2, 3, right? And the second array will have 4, 5, 6. So what we have here is we have two-dimensional array. Okay, now how do you know that this is two-dimensional? So if you have an array and if you want to check, first of all, let's print the array as it is. I would say ARR1, run this code, and you can see we got an array. So this is the output. So we got one big array. Inside that we have two arrays. Now there are certain functions you can apply here. The first function is called as dtype. Now using dtype, you can guess, you will know what type of data you are working with. So at this point, we are working with int. We have another keyword or the attribute you can say, which is ndim. Now ndim is dimension. It will give you the number of dimensions, and you can see the output, it is 2. So when you work with single dimensional array, it will give you 1. When you say three-dimensional array, it will give you 3, right? So it will give you the number of dimensions you have. And plus, it is also called as ranking. So it will rank. So it is 1D array, is it 2D array or 3D array? Now we have one more which is called as shape. So I will say shape here. Now what shape will give you is, let's run this. So shape says 2, 3. Now what it means? It will give you the number of rows and columns. So we have 2 rows and we have 3 columns. So it will give you a tuple with the number of rows and number of columns. The other attribute we have is size. Now using size, it will tell you the size of the entire block, and you can count it now. So we have 3 and 3 to be 6. So let's run, and you can see we got 6. So there are multiple methods you can use, right? In fact, we have one function which is awesome. Example, if I have an array which is ARR2, and I want to create this array 2 with the help of array 1, but this should be 1D array. Okay, so how can you convert a 2D array into 1D array? It's very simple. You will say ARR1 dot. There is a function called as flatten. So the moment you say flatten, it will flat the array, right? So from 2-dimensional, you will get 1-dimensional now. And I want to print, of course, the ARR2. And if you run this code, you can see we got 1-dimensional. So that's how you can create from multi-dimensional to single-dimensional. How about from single-dimensional to multi-dimensional? Because now this is, so ARR2 is 1-dimensional, right? I want to create 3-dimensional. How can we do that? Now, first of all, to make it three-dimensional, I want to have some more values. Of course, then it will work, right? Let me say 2 again and 9. So we got 6 values here, and let me take 6 values here as well. Because 6 plus 6 is 12, and it is easy to create a three-dimensional array when you have this number of values. So I will create array 3, and this should be a three-dimensional array. From one dimension, I want to create a three-dimensional array. So you will say AR2 dot, the function name is reshape. So you can convert a single dimensional array into 3D array. Okay, but then what you have to pass here? So when you say you want to create 3D array, you need to pass the number of, so let's try with 2-dimensional first, and then we'll go for 3-dimensional. So I would say 3 here, I want to print 3. Now you have to pass the number of rows and columns. So I would say I want 3 rows, and the number of columns will be 4, right? So we have 3 into 4, 12. So we have 3 rows and 4 columns. If I run this code, you can see from 1D array we got 2D array. So we got 3 rows and we got 4 columns. Now it is also a 2D because in an array, so the outer array has single dimensional arrays, right? Now what if you have a big array in which you have 2D arrays? Okay, I know that's a bit difficult to understand, but let's try it out. So I will say 2, 2, 3. So 2, 2, 3 is 12, right? So 2 into 2 is 4, 4 into 3 is 12. Now what it will do is it will create a 3D array, okay, big 3D array, and that 3D array will have 2-dimensional array. So it will be having 2-dimensional array, and each 2-dimensional array will have 3 values, or 2 arrays with three values. Okay, let me run this code for you. So you can see this is what I was talking about. It will give you a 3D array, and this 3D array will have 2 2D arrays. So you can see this is one 2D array, this is second 2D array, and each 2D array will have 2 array itself, 2 1Ds array, 2 1D array, and then each 1D array will have 3 values. That's what you're saying. We got one big array which has 2 2-dimensional array, which has 2 single dimensional array, and then which has 3 values. Okay, so that's what you have to say, and you got the output here. So yes, this is some functions you can apply to perform certain operations on 2D array. Now once we talked about 2D array and some operations, the main thing about mathematics, we have a concept. When you talk about arrays in mathematics, we have a concept of matrices. I'm sure you have done that in your college, right? Now when you talk about matrices, what is matrice? You can imagine a 2-dimensional array, right? So we have multiple rows and multiple columns. Now we can have one row and multiple columns, right? We call them as row matrix, right? Or we can have a column matrix which has multiple rows but single column. But ultimately you can represent that with 1D array, right? So even if you have one row, one column, you can say that's 1D. What if you want to have 2D array or matrix format, with multiple rows, multiple columns? We can do that here, right? In fact, the earlier array which we were working with, this is a 2D array, right? So I will just remove all this stuff, and I want to print 1, and I don't want all these values here. Let's reduce it. We can have 2 rows and 4 columns. So if you run this code, this is your matrix, right? But then to actually work with matrix, there are certain operations we can perform. So you have to convert this 2D array into a matrix format. And the way you can do that is by saying matrix M is equal to, there is a function called as matrix, and in this matrix you have to pass ARR1. So you pass a 2D array, it will give you a matrix format. Let's run this code, and this is your matrix. Sorry, not this one. Let me print M. So this is your matrix. I know the output looks similar, right? Output is almost same. What is difference is with this M, you can perform more operations, the operations which we do in matrices. Now this is not the only way of creating a matrix. Example, if you don't have a 2-dimensional array, if you have a string with you, maybe you are taking input from the user. In that case, you will say, hey, I got a value 1, I got a value 2, I got a value 3, and value 6. Now how can I differentiate between 2 rows here? You just have to give a semicolon at the end, and then again you have to say 4, 5, 6, 7. And even this works. If I run this code, so you can say even this works. You don't need a separate array to save the value. You can simply run this code and you can say it still works. If you want to create multiple rows, 4 rows and 2 columns, you can just give a semicolon after every 2 values. So this will convert it into 4 rows and 2 columns, right? So we got 4 rows and 2 columns. So let me just do some modification here because we want to perform some operations here. I will say 3 rows and 3 columns. So you can see we got 9 values. We have 3 rows and 3 columns. If I run this code, this is what you got, right? Now there's a concept of diagonal elements. What if you want to have diagonal element here? I don't want to print the entire matrix. I just want to print the diagonal, which is 1, 4, 7. You can do that with a function called as diagonal. Just say diagonal and pass m, and you're good to go. You can see we got all the diagonal elements. So this is fun. So if you have matrix, you can perform these operations. In fact, not just this one. What if I want to, let's try. So I will say m dot. So there is a function called as min. So you know the answer, right? So when you say min, it means the minimum element. So if you run this code, that is your 1, of course. And if you say max, it will give you the max element. So the operation which we do with array can be done with matrices as well. But with matrices, you get this amazing power. Now, if you remember, if you have done with matrix before, if you have worked with matrix before, we have this concept of adding to matrices. That is very easy, right? You simply have to add the elements. The problem starts when you want to multiply to matrices. Now, if you're thinking, if you want to multiply to matrices, simply take the values from here, simply take the values from here, multiply. That's not the case. In multiplication of matrices, you have to do some rows and column combinations, right? If you remember in matrices, if you have not done that before, I would suggest you to watch my video on how to multiply to matrices. So you'll find the link in description area. But watch that video if you have not done that. And if you know how it works, how will you do in programming? In fact, if you have done C, C++, Java before, you know we have to use multiple loops to make it work, right? So if I ask you to, hey, you need to multiply to matrices, go with C programming, you know, it will take entire 1 page. That's not the case with Python here. What Python says is, if you have 2 matrices, that's well and good. Let's create another matrix here. Let's call this M as M1, and we got this is M2. We can change the values, of course. I will say this is 2, this is 8. Doesn't matter, you can have the same matrix or different one. I want to multiply this. It's very simple. You create M3 equal to M1 into M2. Now this is not a simple multiplication. Okay, first let's try with addition if that works. And at the end I will print M3. Okay, let's run this code and you can see it works. You are adding to matrices. It's straightforward, right? You can just see the combinations there. But what if I say multiplication? Now this is not a normal multiplication. Okay, so if you see the output, it's not normal multiplication. It's not 1 into 1. It is not 2 into 2. It is something different. So this is where you multiply row with column combinations, right? Now this is done automatically in matrices, and that's the amazing thing about Python. We have so many stuff available, right? So I would suggest you to do this manually also. So as an assignment, you can do matrix multiplication but manually. Now how will you know the logic of it? So in the description area there's a video. In that I have talked about the theory of it, how to multiply to matrices. Just look at that video and try to convert that into algorithm and try to convert that into a code in Python, okay? Not using this multiplication. Now till this point we have seen basic stuff, right? We have talked about variables, we have seen arrays, and then we have also talked about Numpy. Now in this video we'll talk about functions. But why do we need functions? To understand this, let's take a scenario. Let's say you are working on a project, and it might be a complex project or a simple project. Now when you have a complex project, what you will be doing is you will be breaking that project into smaller tasks, right? Now, when you talk about that small task, of course, you will be writing multiple statements, right? So example, if you want to perform a payment operation. Now in that payment, you will be writing multiple statements, right? Now all this statement, you can keep it together so that you can reuse later. Example, let's say if there are multiple places where you'll be doing the payment. So of course, you'll be using same set of lines in multiple places, right? So you can put them together. So you can imagine if you want to do any task. So make sure that all the statements of that one task stays together, and it should also be reusable. And that's where we will create functions. Now till this point, we have seen multiple functions, right? We have seen print, we have seen square root, right? We have used most of the inbuilt functions available in Python. Now can we create our own functions? Of course, right? That's the video is all about. How do we create our own function? It's not that difficult. What we do is, so there are 2 steps involved here. The first step is you will be defining a function, and second step is you will be calling a function. So let's go for the definition. So you have to remember the syntax for it. Syntax is you have to say def, that's how you define a function. And of course you have to mention the function name as well. At this point I will say greet, that's a function name. And whenever you work with a function, you have to make sure that you put a round bracket here. So how do your Python knows that this greet is not a variable, it's a function? So you have to give a round brackets there. Now, once you define a function, you have to give a colon because this function will have multiple statements, right? Example, the same way we have done with for loop, if else, right? Because in if or in while you might be having multiple statement. In the same way, in this function definition, you may be having multiple statement. So you will say enter, and this is where you will write your statements. I will say print, I want to print hello, and then I also want to print good morning. So then I want to greet someone with these two things, which is hello and good morning. So what I'm doing is I'm putting those things in a function. Of course, you can do a lot of big things in functions. Okay, this is just an example. So this is just your first step towards functions. So let's keep it simple, and later you can see what a function can do for you. So we got this function, right? Now, this is how you define a function. So step one is you have to say def, and then you have to give a function name. Then you have to mention a colon. In that function, you have to define the statements. So this thing which are together, they are called as suite. Now, once we got this, will it work? Let's run this code. Let's see what happens. The moment you run this code, you can see we got the output, but in output, we are not getting hello, or no, we are not even getting good morning. What's wrong? So the thing is, the function is ready for use, okay? So we have defined the function. So this function will be called only when you are explicitly calling it. Of course, you have to call it, right? How do we call that? The way we call other functions, right? When we worked with print, when we worked with square root, we just have to call it, right? So you have to say greet bracket, right? So this is your function definition. So this is your function definition, and this is your calling. So if you don't call, it will not execute the function. So if we run this code, and you can see we got the output. This is how you define a function. A beauty, right? Now, of course, as I mentioned, using function, you can do a lot of stuff, right? You can ask a function to do something for you. Or you can imagine in your project, your one function is your one helper. So let's say if you are building something big, you need some help, right? So you can say, hey function, this is your job. Hey other function, this is your job. You know, in the industry, the way we allocate project to everyone or allocate the task to every person, in the same way, you can allocate your task to every function. Of course, you have to define the function as well. Now you can call this function multiple times. So let's say if you have a big project of 1,000 lines, and in that, this is the fifth statement. And after some statement, I want to greet. So I will say greet. You don't have to repeat those statements. You don't have to say hello or good morning every time. Just define it once, and you can call it multiple times, right? Let's run this code, and you can see we got hello good morning 2 times. That is what we want, right? Okay, now let's do something different. Of course, we'll be working with functions. What I want to do is I want to add 2 numbers. You know, the simplest example of functions, right? So let's go for addition of 2 numbers. How will you add 2 numbers? I want to say, hey, I want to add, because see, till this point, we have seen multiple functions, right? We have seen square root, we have seen power, but then those functions are inbuilt. And of course, we have to pass parameters as well. So when I say parameters, the variables, the data which you want to perform. Example, when you say square root, in the bracket, you mention for what value you want a square root of. So here as well, in this add, you have to pass a value. I will say, hey, I want to add 4 and 5. I don't know the output. I just want to add these 2 numbers. But the question is, do we have this function available? Of course not, right? So we need to define one more function. Now this is a different function here. So we'll say def, and we have to mention a function name, which is add. Now this function will take 2 parameters. Okay, now this is important, okay? Remember this keyword called as parameters, or you can say arguments. So normally we can call them as arguments. So we'll say we have to pass 2 arguments here. One is x and y. So whatever value you're passing from here, which is you're saying add 5, 4, you have to accept it somewhere, right? So you have to say x, which will have 5, you have y, which will have 4. Then you have to give a colon, not so far. And here you can perform your operation. So I want to say c is equal to x plus y. That's how you add 2 values, right? Or 2 numbers. Now, once you have done the addition, you will simply print it. Now, the advantage is next time when you want to add 2 numbers, you don't have to say c equal to x plus y. You don't have to perform this operation. You just have to call this function called as add. By passing the values, it will add for you. Again, we are focusing on simple stuff. Normally, when you work on a project, you do complex tasks with one function. Let's run this code. Let's verify if it is working. And you can see we got 9. So yes, it is working. Now you can see we have not got hello good morning because we are not calling greet, right? So if you want that output as well, we need to call them. So important thing is you can create multiple functions and you can call them as many times as you want. So this is fun, right? Now there is one more thing you can do. See, as a function, you have 2 choices. One when you call a function will do a task for you. So the function which is you are using here is simply printing it, right? Then we have another type of functions which will return you the value. Example, let's say I don't want to actually print the value. I just want this addition of these two numbers, and then I want to save it in some value. I would say result. Example, when you worked with square root, remember when we worked with math module and then we had square root? The square root function was giving you something, right? So your function can return a value as well. To understand the scenario, let me just take an example here. So let's say if you are watching this video, and so let's say if your name is Rahul, so I will say, hey Rahul, call Tina and say, tomorrow I will be late for the session. So I'm not expecting anything in return, right? That's one scenario. The second scenario is I will say, hey Rahul, ask Tina what time we have a session tomorrow. So this is where Rahul as a function will return me something. So function can be of two types. A function will execute the task, or a function will return you something, right? So in this scenario, I'm expecting something. So when you define a function which will return something, you have to do that. You have to say, instead of printing it here, because I don't want to print, I will say return, and then you have to return C. So return is a keyword which we use to return the value. So what you're doing is you're saying, hey, add function, add these two values and give me the addition. Okay, so whatever the addition is, it will be assigned to this result. Now it is your choice if you want to do if you want to print result, if you want to store this result into database, or you want to post this result on Facebook. I don't care. What I care is I am giving you the value. I'm not responsible to print it. I'm not responsible to put that value on Facebook. I'm responsible just to add those two values. You can do whatever you want. But then here, I just want to print it because I don't want to write a code for Facebook here. So I will say result. And let's run this code, and you can see we got the output. So this is important. A function can return a value. A function, you can write a function which will not return a value. Okay, this makes sense, right? Now time being, just to make it clean, I will not be using this greet thing. So this is how you can define a function. What if I want to return two values? Because see, we are passing two values, right? And we are returning only one value. What if I want to return two values? But what two values I will return? Let me just change this to have another name called as add and sub. So the function name itself is add sub, and you can guess it now. This will provide you two things, the addition and subtraction as well. So let me take two variables here. One is C and one is D, and D will take X minus Y. So in total, we have two results here, C and D. I want to return both. So I will say C, comma D. So yes, you can return two values, okay? So you can call a function will accept two values or multiple values, your choice, and you can return multiple values. Okay, but there's one problem. You can see we are getting error here. It says unresolved. So we'll say, hey, function name is not add, it's add sub. Okay, and we are passing two values, 5 and 4. That's perfect. But don't you think we are returning two values? So when you return two values, you have to accept two values. So we'll say result 1, comma, result 2. So when you're returning two values, you have to accept two values as well. And here you can print result 1, comma, result 2. So you can do that. Let's run this code, and you can see we got 9 and we got 1. So from one function, you can return multiple values. Now trust me, once you start working on projects, this thing is very, very important. Okay. So at this point, just remember, function is a block where you will have one task. So if you want to achieve one task, just write a function for that. It's always a good practice to have a separate function for separate task, right? So that you can call them again. In fact, there's one advantage, in future, if you feel that you want to modify something, if you want to modify one code, you will be changing only one function, right? It will not affect other functions. You can test a particular function individually. So it's always better to create a function, okay? So next time when you work on a project, make sure that you create functions. Till this point, we have talked about functions, right? And we know now how to create functions. Now, again, when you have a big project, and if you want to break down your project into smaller tasks, each task can be represented with the help of function. And those things are reusable. That's why we define in that one particular block, right? When you want to use a concept of modularity, we use a concept again of functions, and then we create modules. Again, we'll talk about them later in detail. Important point here is, when we talk about functions, of course, we call them, right? So again, in this example, we'll focus on two things. The first one is how to pass a parameters to a function, and what happens with the variable when you pass it to a function, okay? If you modify the value, what will happen? Again, we'll see that. And then we'll also see different types of parameters we can pass, or you can say arguments you can pass, right? So let's get started. Now let me define a simple function here. I will say def, and you can go with any function name, doesn't matter. I will say update, okay? You can say modify or any function name, doesn't matter, right? So we have a update function. Now this update function will take a value from a user, and let's say the value is in a variable called as x. I love this variable name x. So we have a function which is update, and we are passing a variable x. Inside this update, I will be saying x equal to 8. Now you tell me, if I update the value and if I print it here, of course, will it get updated whatever value you pass? Let's try. What I'm talking about is if I call this function update by passing a value 10. So initially the value of x is 10, but then later we are saying, hey, I don't want to use the value 10. I want to change the value to 8, and then I want to print it. So will it print 8 or will it print 10? So think about it. Of course, right, it should print 8 because we are updating a value, right? So let's run this code, and here we go. We got the output as 8, so it works. That's great. So we are getting the updated value. What will happen to the value? Example, if I create a variable here outside this, if I say there's a variable called as a, and the value for this a is 10, and I'm not passing 10, I'm passing a. So basically I'm passing the value of a. So we are passing 10, right? So the value of a is going to x now. Let's run this code. This works. Now let me print the value of a. So what do you think? What will happen now? Of course, the value of x. So this print will print 8, of course. What about this print? Will this print 8 or 10? That's a question, right? Because here we are printing the value of x. Let me just specify that explicitly there. So here we are printing the value of x, and here we are printing the value of a. So this is what we are doing, right? So let's run this code again. So what do you think? Will it update the value for a as well? And if you run this code, you can see a is still 10. So even if you're updating the value for x, it is not affecting a. So we have a concept called as pass by reference and pass by value. So if you have learned other languages like C, C++, we have this concept there, right? Pass by value and pass by reference. So what happens in Python? Is it call by value or call by reference? Let me just give you a thing what is call by value is. Now, whenever you say you are calling a function by passing a variable value, it will be passed as a value, not as a variable. Example here, when I say update a, I'm not passing a, I'm passing 10. That's important, right? I'm passing the value of 10. Okay, I'm not talking about Python here. Okay, I'm talking about the general concept of pass by value and pass by reference. So if you say it's a pass by value, it simply means you're passing a value, not the address. But in pass by reference, you're passing the address itself. Now, why it's so important? Example, if you pass a value, now whatever happens with that value, this a is not concerned about it, right? Because the moment you pass a value, it will use a different memory, right? So when you say pass by value, it will say if you pass 10 or if you pass the value of a, the x will get a different memory, okay? Different memory of 10. So even if you update that 10, it will not affect a. That is pass by value. The next concept is pass by reference. Now what is pass by reference is you are passing the address, which means you are not passing 10. You are passing the address of a, which means the moment you change the value for x, it will affect the value of a. Okay, that is called by reference or pass by reference. What happens in Python? What if I say in Python we don't have any of this concept? We don't have pass by value, we don't have pass by reference. So Python is different here. Now, before changing the value, what I will do is, before changing this value, in fact, we have talked about this before. Everything in Python is object, right? Everything is object here. So if I pass a value here, example, if I'm passing a, and before calling update, let me print the ID for a. It should print some ID, and let me print the ID of x as well. Now, if there are two different variables, we'll be having two different IDs, right? Of course, there are two different variables, but if they are taking two different memories, they will be having two different IDs, right? Let me run this code, and you can see before updating, we have the same memory. That means when you pass a value, they are still referring to the same object, okay? A and x refers to the same object. So of course, this is not passed by value. Is it called by reference or pass by reference? Not exactly, because in pass by reference, when you change the value, it will affect the original value as well. So this is none of them, okay? The moment you change the value of x, and if I print the ID of x in this case, Okay, let me just read on this. So you can see we are updating the value. So this, we got a new ID. So the moment you change the value, it will give you a new ID. In fact, we have talked about this in a video called as mode on variables, right? So we have talked about this before. So remember this point. Whenever you pass a value to, when you call a function by passing a value, they will share the same ID, the value which is the variable data which has been passed and the variable you're accessing it here. But then the moment you change the value, it will change the address. Okay, normally if you're going for interviews, they might ask you this concept, so in Python, what we use? Is it pass by reference or pass by value? So answer is none of this. We don't use any of them here. The reason when you change this value, it will create a new memory is because integers, string, they are immutable, right? What if you use something which is mutable here? Example, instead of having this A, let's imagine this is list. And in this list, we have certain values. Let's say we have 10 and we have 20 and we have 30. Now, in this case, when you have these three values, and if you are passing this list, okay, let me just print the ID as well. And I want to update the list, not a normal variable here. And I want to print the list as it is. And here as well, I will change the name of it. It doesn't matter if you use the same variable, okay, it works, even if you use same variable name. And if I say LST, let me change a value for LST. I will not change all the values, I will change only one value. I want to change the index number 1, I want to make it 25. So it should be 10, 25 and 30, that's what I want. Now I'm changing the list, right? Will it change the ID? That's the question. Let's print the LST here as well, and let's run this code. And you can see we got the updated value here. That's perfect. And it is also updating the original list, is it? Yeah, it is updating the original list as well, because the ID is same, right? Because since we have the same ID here, it will not change. So it is mutable, right? So that's the idea behind list here. So we have talked about something amazing. Now till this point we have talked about functions, right? And now we know how to pass parameters as well. But when you talk about parameters, or you can call them as arguments, we have different types of arguments we can work with. Of course, arguments are arguments at the end, but then we can use in different way. So what I'm talking about here is, let's say I want to add two numbers. A very simple example, I would just want to add two numbers here. So what I will do is I will say def, I will get a method name as sum, the function name as sum, and here I will mention two variables, of course, right? When you want to add two numbers, we need to ask for two values, right? And we can give them name as A and B. So in A will be having the first number, in B will be having second number, right? And in order to define that, we have to put a colon at the end, and you will say C equal to A plus B. Now you have a choice here. You want to add, you want to print the value here itself, or you want to return. But that's not the main concern for this video. So time being, I will simply print it. What is important here is when you call this function which is add, you have to pass two values. You cannot simply say add, right? Of course, you have to pass values. So when you are accepting an argument here, you need to pass the argument as well. Otherwise, it will give you error, right? You can see. So when you press the control button and if you hover there, it says we have to pass two parameters, right? Now in that case, if I pass 5 and 6, so we are passing two values, right? Now these are called as arguments. So the things which are accepting here, they are arguments. Even this is an argument. Now this A here, so this A, B here, they are called as a formal argument. So we have two names here. We have formal arguments and we have actual arguments. So when you define it, it is formal. And when you pass the value, when you are calling a thing, which is called as actual argument, because you're actually passing something, right? So this actual itself, the actual arguments has 4 types. It is position, keyword, default, and variable length arguments. So let's start with the first one. Again, it's not that difficult, it's just with different names. Okay, so when you pass a value, example, if I want to pass 5 for this A, of course it is position, right? In fact, just for this example, we will take a different names, okay? We will take a different method name. I will say the function name is person, and instead of, so when you talk about a person, there are two things that are very important here. The first one is name, and second one is age. So we want these two parameters. And of course, you have to pass them as well. So if I change this, let me just change all the values here. So I have defined the function which is person. It takes two arguments. One is name and age. And so I'm calling person by passing name and age. So name is Naveen and age 28. So if I run this code, you can see we got the value. It is working perfectly, right? Now, how do we know that this Naveen is going in name and 28 is going in age? So that's where positions comes into picture. If you have 10 variables and if you want to make sure that it is the values are assigned to the particular variable, we have to take care of the position. You cannot simply exchange the position, okay? So positions are very important here. So when you are only depending on the positions, then of course we have to maintain a sequence. But what if I don't know the sequence? So let's say I have defined this function somewhere else, okay? I don't have the access to this function. What I know is there's a person function which takes two parameters, name and age, but I'm not sure about the sequence. In that case, example, if I forgot the sequence here, and instead of passing Naveen first, I'm passing 28 and then I'm passing Naveen. This is where the problem starts, you know, because we are passing a number first and then we are passing a string. Of course, in this case, it will work. It will not give you any error. Of course, you will get the output in a different format, the way you are passing. But let's say if you are performing some operations on age, I want to print the age -5. That's what we all do, right? So whatever age is, we always say -5 with that. And if I run this code, you can see this is where the problem starts, because you cannot simply subtract a number by a name, because so Naveen is getting passed in age, right? That's where the problem is. I don't want to do that. I don't want to assign the value 28 to name and Naveen to age. In that case, if you don't know the sequence, you can simply say, hey, age equal to 28 and name equal to Naveen. So in this case, we are using keywords, right? So when you say keyword, it means you are mentioning the variable name itself. So variable is age, which is 28, and variable is name, which is Naveen. In this case, it will work. Okay, you can see we got Naveen and 28. So this is the keyword arguments. The next argument is default. Now what it means? Example, I want to pass a name and I don't want to pass an age, because by default, like, let's say if you want to open an account in social networking website like Facebook, maybe there's a criteria that you should be 18 to join a Facebook profile. Now in this case, if I pass a age, that's well and good. If I'm passing an age which is 28, that's well and good. What if I don't pass the age? So in that case, what I want is, by default, the age should be 18. So if I'm not passing the age, which means it should be 18. But in this case, if I run this code, it will give you error because you are expecting two variables and we are passing only one. This is wrong, right? So in this case, what you can do is you can mention, hey age, don't feel bad. While calling a function, if you're not getting the value, don't worry, just assign the default value. That's completely fine. Just run this code and it works, okay? So if you're not passing a value, it will take the default value. But what if I pass a value? In that case, it will override the existing default value. So you can see in this time it was 28. That's default. So once we have talked about default, keyword, and position, let's go with very important function arguments, which is variable length arguments. Now what that means? To understand this variable length argument concept, I will change the function again. Let's get back to sum, because it will make much more sense there. Of course, you can take different example, but then let me take sum there. Or we can say add function, but let's say sum. Sum takes two parameters, a comma b, and here I just want to add those two values. I will say c equal to a plus b, and I just want to add them now. I want to pass 5 comma 6, and of course I missed one thing. I want to print the sum, which is c. Okay, now will this work? Let's verify. So if I say shift F10, it works. You can see we got 11. So when you say you want to add two numbers, right? See, we don't always add two numbers. Maybe sometime we want to add three numbers. Maybe we want to add 5 numbers, because in calculator we can do that, right? We can say 2 plus 3, and then we can also say plus 4 plus 5 plus 6 plus 10 plus 100. We can do that. How can I pass multiple values here? So maybe as a user, you want to say, hey, I'm not sure how many values I want to add. Maybe I will pass 2 more values. You should be able to do that. Okay, so as a developer, it's your responsibility, right? If you're defining a function, make sure your function accepts multiple values. Then what you will say, hey, we will create multiple functions, you know? We create multiple functions with different parameters or different arguments. We can do that. But the thing is, don't you think it will be very lengthy process? So that's where we have a variable length argument concept. What it means is you can define a function where the number of arguments are not fixed. So in this case, you can say, hey, at least we have one parameter, right? At least we'll be having one argument. Of course, if you want to add two numbers, we will be having at least 2 arguments. So the first one is confirmed. The second one, length, is not confirmed. So in this B, I might accept one variable or one value or multiple values. In that case, you will say star B. Star B means it can have multiple values. So this 5 will be assigned to this A, and this 6, 34, and 78 will be assigned to B, okay, as a tuple. Now let's run this code, let's verify. Okay, we got an error. The error is, see, there is no error while calling it. The error is with the help of int and tuple, right? So we cannot simply add an integer and a tuple, because A is integer and B is tuple. Okay, and how do we add this value? That's the question, right? So first of all, before adding these values, what I will do is I will print the value of A just to verify what is happening, and I want to print the value of B just to verify. Let's run this code, and you can see we got 5 and we got a tuple which is 6, 30, 34 and 78. So it perfectly makes sense, right? Now how will you add this value? Of course the first value is fixed, so what we can do is we can say C is equal to A. Initially C will have the value of A, and then we'll fetch one value from the tuple and we'll add it to C, right? That's the plan. So I will take for I in my B, which is tuple, and in this case I will say C is equal to C plus I, right? That's how you iterate. So every time your loop runs, it will add the new value to C, and at the end we'll print the value of C. That's the complete idea. Let's run this code, and oh, we got an error. Okay, that was an indentation problem, you know, so I have given one extra space, and you can see it works. We got 123. That is what we wanted, right? So this works great. In fact, we can do some customization here. What if I say I will simply mention B star? Okay, so it doesn't matter how many values you pass. Why do we even need A there, right? So if I pass 4 values, everything will be there in B. So in that case, initially you will say C equal to 0. That's the only change you have to make, and everything works the way it is, right? So because you're not passing A, so we are not using A, so let's remove A, right? So that's it. That's how we use a variable length argument. So in fact, it's not just integers. You can pass integers, string, or float together. That's fine. You can try it out. Now to this point we have talked about functions, and now we know how to pass parameters or arguments to the function, right? And we have talked about different types of arguments we can pass, like we have keyword, we have position and default, and then we have talked about very important topic, which is variable length argument, right? So let's continue with that, and we just need to complete one small topic in that. So what I will do is I will simply create a function here which will take some data from the user. Okay, now it will be a person data as we did last time. So there's a function, the function name is person, and it takes some parameters. Okay, that's nothing big, and the parameters which I want to pass is something like this. Okay, so what I will be doing with those parameters are a different thing. Okay, here the important thing is I have a person function, I want to pass some arguments. Okay, when I say parameters arguments, you can imagine they are same. Okay, so we have person here, and then a person want to send different data. Example, a person want to send the name, so I will say Naveen, and then I want to pass my age. I want to pass, let's say, the city which I live in, so I will say Mumbai, and then I will also mention my phone number. Let's say that is 97654. So we have a phone number here. So we have a name, we have age, and we have city and a number. Now, when we talk about a function person, of course, the most important thing is name here, right? So every person is a name. Doesn't matter if you want to reveal your age, or you want to reveal the city you live in, or maybe your mobile number, but name is something which we all reveal. Now here, I may want to accept one parameter. So we'll say, hey, I will say, okay, name is something I will get for sure. So name is something I will get for sure. But I'm not sure about the other parameters which a user will be sending. Maybe a user will send age or city or number. I'm not sure. Now in this case, of course, we have seen this, we have to accept a variable length argument, right? So in this case, you will say star and you will say data, right? So you will say other data. But there is one problem here. The problem is, even if we try to work with that data, let's say I want to print all the data here. Now anyway, this data is tuple, right? So if you want to print all data, you will be using a for loop. Before that, what I will do is I will just print the name first. I will print a name here. And then I also want to print the data. So I will say print data. Now, of course, this data will be printed, and it will be printed in tuple format. So I will say run this code, and you can see we got data. We got name and we got data as well. That perfectly works, okay? But the problem is, if I want to print this individually, and I don't even know what a user is sending. What is 28? Is it the phone number or the age? What is Mumbai? Is it maybe the state? So we have to convey our message in a proper way. Maybe Mumbai is a workplace or a home place. You never know, right? So in that case, so we also use a concept called as keyword variable arguments. Now the difference is in variable length arguments, you pass a number of parameters, right? But you have to also mention the keyword, okay? Example, I will say, hey, this 28 is my age. This Mumbai is the city which I live in. This is my mobile number. So I'm also sending a keyword there, right? Now if you want to work something like this, because if I run this code, you're getting an error here. It says got an unexpected keyword argument age, because When you say star, it will not accept a keyword arguments, and that's where you will say star. So when you say double star, it means you are passing multiple arguments but with the help of keywords. And the moment you run this code now, and you can see it works, we got the data, yay, okay? So it's so simple, right? So if you want to pass multiple data and that too with the help of keyword, then we have to use keyword variable length argument. Makes sense, right? In fact, here we can also use a for loop to print the key and a value pair, you know? So we can say for, and we have two things, right? We have a key and a value, so I will say, so we have to say for I comma j in, and then you have to fetch from data, right? In fact, in normal books or projects, we normally write KW, which is keyword arguments, but that's fine. You can use any name here, it doesn't matter. So here you will say for I comma j in data. So you cannot simply say data, you have to say items, right? So you have to use a function called as items, and then you will print one data. You will print I, and then so you will say, so you will simply print I comma j. You will print the key and a value pair, right? So let's run this code, and that's what you got. So you got Naveen, you got age 28, you got city Mumbai, you got mobile number. Now we have talked about variables and we have talked about functions, right? Now when it comes to functions and variables, of course we will be creating variables inside a function, and normally we can create variables outside the functions as well. That's where a concept comes into picture called a scope. Now what is scope here? So let's say you have a normal variable, right? So let's say I will take a variable called as a, because we all love this later. We have a variable called as a, and the value for this a is, let's say, 10, okay, very simple. And then I want to create a function. So I will say a function. Of course, I want to print this a as well. So I will print the value of a here. So of course, when you run this code, it will be 10, right? We are not doing anything else, so we got 10. But let's say if I define a function in between, okay, and this function name is, let's say, something, because we don't care what the function name is. So we got a function name called something, and in this something function, I'm creating another variable. I'm saying the variable name is again a. Oh, that's weird. So we have a variable again a, and then I'm printing the value of a here. So you can see we have two variables. Now, is it possible to create two variables in the same code? Yes, if they have different scope. Example here, this a, the a outside the function, it is called as a global variable, and the a inside the function is called as a local variable. So it is local, right? Local to the function. Which also means you cannot use this variable outside. Example, if I create a variable here which is b, and if I say b is 8, and then if I try to use this variable outside here, if I say print b, so it will not work, you know, because we don't have a b variable. You can see we are getting an error which is unresolved reference. Now, of course, we have b, but it is inside a function, right? So the scope of that variable is inside the function. But what about this a? Again, this is a local variable, so the scope of that a is inside the function, and scope of this a is everywhere, right? So you can access this a from anywhere in the file. Okay, that's perfect. Even if you have 10 functions, you can use that a. So now the question is, if I run this code, what do you think the output would be? In fact, I will print here function. At least we'll know from where you're getting the output, right? So here I will say outside. Okay, so we have in function and then we have outside. Okay, so you tell me, what will be the output? So this in function a will print 15 or 10, or this one will print 10 or 15. Now, first of all, we are not calling something, right? Of course, something will not be called then. So we have to call something as well. So now let's run this code and let's see what happens. The moment you run this code by saying shift F10, you can see we got the output which is in function 15 and outside 10, which means the local variable inside the function, the preference, okay, that's important. The preference will be always given to the local variable, right? So that's why we got in function a. So this a is a local variable, and that's why you got 15, right? Now, what about outside? So this will print 10 because this is what you are accessing here, right? You cannot access the local variable outside the function. Okay, that's perfect. But what if I don't have a variable here? So in this case, if you don't have a variable inside the function, can I use this global variable inside a function directly? You can see there is no error as of now, but if I run this code, okay, it works. So you can see we are able to get that here. That's perfect. So we can access a global variable inside the functions as well. That's so simple, right? Even if you have 10 functions, you can access that variable anywhere. But here's a twist. What if after, let me change the value of it. I will say the value of it is 15 now. So I'm changing the variable a to 15. But is it a local variable or the global variable now? Because I'm changing it, right? That's where the problem starts, because till this point we were thinking that's a local variable, but I want to change the value of a global variable now. Every time you say A15, it will create a new variable, and you can see the outside, the global variable is still 10. Okay, now how do I change it? So if you want to specify, hey, this A which we are using here is not a local variable, it is a global variable, in that case you have to mention explicitly global A. So this is where you are specifying to Python, hey Python, my intention here is to use a global variable, not the local one. Okay, that's why I'm saying global A. And now if you run this code, here you go. You can see that the outside, the global variable also is 15 now, because the change is not on the local one, because we don't have a local variable here. Okay, we don't have a local variable here. This is a global variable. Simple, right? So this is how we refer to a local variable and a global variable. So if you want to use a global variable, you need to use a keyword called as global. Okay, of course you can access it, but the moment you reassign the value, it will create a local variable. We don't want that, right? And that's why I say global. So this works. But there's a problem here. If you say global A, which means in this function we have a variable now, and if you want to create another A variable, you cannot do that. Example, once I go ahead and if I say A equal to 9, now I want this A to be local variable. Can we do that? Can we have a global A and local A in the same function? It's not possible, because the moment you say A now, it will treat that A as a global variable. Oh, so that's the problem now. So we want to achieve, we want to use a concept of global and local in the same function. So in that case, of course, this is not a good idea. So we will not use this. We will create a local variable which is A equal to 9. So we want that. Okay, let's not change it. So the idea here is we want a local variable A, but we also want to change the global variable A. How can we do that? So that's where we have a special function called as globals. Okay, so using globals we can access the local variable address. Okay, so the global variable address. So what we can do is we can say X. So see, we just want to get the access to that A, right? The global one. So you will say X equal to, there's a function called as globals. And now this globals will give you all the global variables, okay, not just one, because you might have multiple variables, right? You will say you have B equal to 9, you got C equal to 9. So you might be having different multiple variables. In that case, so when you say globals, it will return all the global variables, but we only want one, right? So in that case, you need to specify, hey, I want a global variable with a name A. So we are trying to get the access of that A. Okay, now if you want me to prove it, let me just do that. So let's also print the IDs of the variables. So I will say print the ID of A and also print the ID of X. So if they are same, if they are pointing to the same address, that means our job is done, right? So let's verify. See, look at the IDs now. So both the IDs are same. That means this X is also referring to the same value, which is 10. Okay, that's important. And now we can change the value. So if you want to change the value, don't change the value of X, because the moment you change the value of X, it will create a new variable called as X. So we have seen that before, right? If you change the value of X, it will just create a new memory. In that case, what you will do is you will say, if you really want to change the value, so you will say globals of A. Instead of creating a different variable, simply say globals of A is equal to 15. So now what you're doing is you're changing your global variable. Okay, that's important. So if you want to change the global variable A without affecting the local variable, that's why you will use globals A. And you can see the global variable now is 15. Oh, and you can see that we got in function 9, which is the value of local variable A, and we got outside 15, which is the global variable value. Okay, that's fun. So this is how we use global and local in the same function. In fact, if you can also print the value of X, which will give you the initial value of A, which is 10. So that works. This is how we use global and globals in Python. Now till this point we have talked about functions, and in that functions we were passing some arguments, right? So we tried different type of arguments. We have tried positions, default, right? Now can we pass a list of elements? Is it possible? Because see, we were passing 1 or 2 elements, or we were using the variable length argument. Can I pass a list? So we'll try a simple example here just to make you understand how can you pass a list, and then we'll try to return multiple values, not just one. A function can return multiple values, right? We have tried that, we have done that. So we will create a function which will take multiple values, or which will take a list and it will return multiple values as well. So if I pass a list, in that list you will be having multiple values. You just need to return the number of even numbers and odd numbers, right? So we have to return two values, the number of even numbers and number of odd numbers. So the problem statement is, if a user gives you a list of elements, you need to pass that list in a function. That function will return you the number of even and odd numbers, and then you have to return two values, right? So let's do it. So what I want is, I want to create a function which will return me two values. One is even number and odd number. I mean number of even numbers and number of odd numbers in the list, and the function name is, let's say, count, and this count will take a list, right? And we don't have a list here, so let's get a list. So the list is equal to, again you can take this input from the user, okay? So you can try that as an assignment. You have to take this list as a user input. So let's take the input from the user. Okay, so now we got some values, okay? I don't know how many even numbers and odd numbers are there. Let me just count it here. So we got 1, 2, 3, 4, 5, 6. I guess we have 6 even numbers, and then we have 1, 2, 3 odd numbers. I guess let's count it with the code, okay? And that's why we create softwares, right? Because we are very bad with calculation. So here I will just pass the list and it will count. So we don't have this function count here. So let's define it. So I will say define count, and this will take a list, of course, and let's define it. Let's create something. So I will take two values here. One is even, which will count the even numbers. Initial value of even will be 0, and we'll say odd numbers. Initial value of odd will be 0. Okay, now once I've got these two variables, the next thing we have to do is we have to use a for loop, right? Because we need to increment the values. So I will say for I in LST, and every time you get an even number or an odd number, you just need to increment even or odd, right? So in this case, you will use a condition, if else, right? So you will say if I mod 2 is equal to 0, that means it's an even number. If it is true, then you will say even plus equal to 1. That's simple, right? And then in the else part, you will say odd, right? So odd plus equal to 1. So every time you get the even number, you will increment the value of even. Every time you get an odd number, you will say increment the value of odd. Now once you have done that, you will simply return two values now. One is even and one is odd. So there is no compulsion that your variable name should be same as the global. So you can see here we are using even, here we are using even. So there's no compulsion that it should be same. You can say EO, that's fine, completely fine. Now once you got these two variables here, let's print even and also print odd, okay? And let's run this code, and it works. You can see we got 6 even numbers and we got 3 odd numbers. You can actually count it, okay? Or you can also print this in a proper format. I'm not a big fan of format, but let's try. So I will say even, and then I will give a colon. I want to print even colon value and then odd colon value. So here I want to replace this with the actual values, right? So the curly bracket should be replaced with the actual value, and that's where we use a string, which is even number and then odd. We have to use dot. So in string we have this option of function, so we have to say dot format, because this format is a function belongs to string, and we have to pass two parameters here. The first one is even value and odd value, because we have to replace two formats, right? This one and the next curly brackets. And let's run this, and we got it. We got even 6 and odd 3. So that's what in this we have talked about. Now in this video, we'll try an example where we'll try to find a factorial of a number. Now what is factorial? So if I give you a number 5, you have to say 5 into 4 into 3 into 2 into 1, or you can say 1 into 2 into 3 into 4 into 5, right? So ultimately the answer will be same, right? So if I say factorial of 5, this is the value. If you say factorial of 4, this is the value, right? So I want to execute this in a programming, because a user can give you any big value, right? So you have to find a factorial of it. Normally, if you want to achieve this, of course, you have to start with 1 and you have to end till the number, right? Or you can go in reverse order as well, but let's go in ascending order. So what I will do is, I will say, hey user, a user will give you any value. You can actually take the input from the user. But time being, let me assign a value. I would say the value is 5 here, and I want to call a function which will give me a result, and I will call the function as fact. Again, you can do this without functions as well, but since we are working with function, it's a good practice to do it in that way, right? I will use a function called as fact, in which I will pass x. See, I don't know what this function will do at this point, but then I'm saying, hey, I want a fact function which will give me a factorial of a number. But unfortunately, we have not defined that yet, so we'll do that, but I want to also print the value of result. That's the main job we have here. But of course, we don't have this fact function, so let's define it. The way you define that is by saying def, and you have to mention the function name, which is fact, and you have to pass a variable, or you accept a variable which will say x. Again, there's no compulsion that you have to use the same variable. In fact, we'll use a variable name as n. Okay, we'll give a colon, and here, how do I find a factorial here? So if you see the example here, when you say the factorial of 5, you have to go from 1 to 5, right? So of course, we will be using a loop. So we'll say for I in. Now we want to start from 1 and we have to go till 5, right? And that's where we will use range. Now in range, if you specify only 5, then it will start with 0, it will end at 4, and that's the issue. I want to start from 1 and we have to end at 5. In that case, I will start with 1, not with 0, and I have to end at n, right? So we have to say n plus 1, because if I only say n, it will stop at 4. We want to stop at 5, right? We'll give a colon, and this is where you will do the calculation. But after every calculation, we have to see, ultimately we have to say 1 into 1, okay, because we want the initial value, and then the result will be multiplied by 2, that result will be multiplied by 3, that result will be multiplied by 4, right? That's what we want to achieve. So in this case, I will take a variable called as f equal to 1. Initially the value of f is 1, and every time this loop runs, you have to say f is equal to f into I, right? So if the I value is 1, then f into 1 will be 1. If the value of, the value of f is 1, right? If the value of I is 2, then the value of f is 1, right? 1 into 2 is 2. And then the value of f now is 2. Then you have to say, the value of I will become 3, so you have to say 2 into 3, right? So that's how it goes. And ultimately, you have to return the value of f. That's simple. Right? So if I run this code, you can see we got the factorial as 120. Now if I change the value to 4, the factorial of 4 is 24. Let me just verify. And that works, right? Now you can also use, you can also do step-by-step here example if I want to see how it works. So I will start with this point, that's the execution point, and I will say run and debug. Let's do step-by-step here. So for next step, for the step 1, we have f8, so let's do that. So I will say f8, and you can see the value of x is 4. Okay, and then we are calling the fact function, and fact function is giving me 4, right? We can also do that here. We can apply a breakpoint here. Let's do that. So when you say f8, you can see the value of f is 1, and it goes into I. The value of I is 1. The value of f is also 1. It will be multiplied. The value of f becomes 1 now, and then when you go back, I becomes 2. The value of f changes to 2. You can see that. And when you go back, I value becomes 3. The value of f becomes 6, right? That's important. When you go back, I becomes 4. The value of f now becomes 4 into 6, which is 24. And then the value of, right, so that's the end, right? We have to reach till 4. And if you return, the return value would be 24, right? That's what we got, right? That's simple. So that's how you can do the factorial. Now in this video, we'll talk about a topic which is my favorite, called as recursion. Now what is recursion? So generally when you talk about recursion, it means you are calling a function from itself, okay? So you're calling a function from a same function. Now what I mean by that is, let's say we have a function here, and I will call that function as greet, okay? A simple function called as greet, and this function does nothing but it prints only hello. That's it. So we are printing hello, nothing else, hello, right? And I want to call this function, right? So of course we have to go out and say greet. Okay, so if I run this code, of course the output will be greet, right? So if I run this code, you can see the output would be hello. That's perfect. Yeah, so let's say I want to print this hello multiple times, a lot of times. So what you can do is, of course, we can use for loop, right? But there's one more way. What if you call a function again? So what you're doing is, you are calling greet once, okay? So at this point, you're calling a greet function. Then this greet function is getting executed, and this greet function again is calling the greet function. I mean, it prints hello, and then it is calling itself. That is recursion. So what do you think? How many times it will get called? Is it 1, 2 times? Because if once we are executing it, that's for sure. But only 2 times, or 3 times, or 10 times, or 100 times, or infinite times. Okay, technically it should be infinite times, right? Because you're calling itself. So a function is calling itself. So greet is calling greet is again calling greet is again calling greet. So it will just go on. And that's where, if you run this code, you will get a lot of hellos, right? You can see we got all hellos. If I scroll up, you can see the scroll bar there, if it is visible. So there's so many values here, and at the end it will give you an error. See, technically it should be infinite, but then there's a limitation, right? See, why we have to put a limit here? Because by default, you can do this recursion only for 1,000 times, okay? That's a limit. So you can see it says maximum recursion depth exceeded. So by default, the limit is 1,000. You cannot go beyond that. Of course, you can by doing some customization, but time in, it will go till till 1000. But you will think, why 1000? If you want to go beyond that, or if you want to go for infinite, why not? The problem is, see, sometimes as a programmer, you write a code and your intention is not to go into recursion, but by some, due to some mistake, you are going into recursion. And if your code goes into recursion without condition, and if it is going infinite time, your system, your software will hang. Okay, so Python takes care of that. So Python says, hey, I will give you only 1000. If you want to change it, you can do that. So I want to actually count, okay, how many times it's going. You can see it says there should be some number here. Okay, there's no number. Oh, there's a number here. It says previous line repeated 992 more times. Okay, so basically it is 1000 limit. In fact, we can actually print, okay, what the limit is. So the way you can get the limit is, first of all, you have to import sys if you really want to know the limit of recursion. And the function is, okay, so we'll print. So we'll say sys dot. There's a method called as get recursion limit. Okay, so you can see that the moment I say sys dot get recursion limit, it will give you the limit here, and I will not call greet at this point. Remove that, and if I run this code, you can see the limit is 1000. Okay, so that I'm not executing this function greet. Okay, so I'm not calling greet, so it will not getting executed. So the limit is 1000. Okay, we got that. How do I increase the limit? So the way you do that is by saying sys dot set recursion limit, and you can provide any number here. Okay, now when I say any number, I tried with 2000, it worked. Maybe you can try a different number. Let me know in the comment section if it is not working for big numbers. And now if I run this code, you can see the limit has changed to 2000, which means if I call greet, it will print hello at least 2000 times. If I run this code, you can see it says, oh, okay, how do I know how many times it's getting printed? So what I will do is I will take a counter here and I will say counter is 0. Initially the counter will be 0, and before printing hello, I just want to increment the counter. So let's also print the value, and now let's run this code to see till what point it is going. Oh, the problem is, okay, there's one problem. See, I is a global variable, right? And we are trying to use that variable inside the function. So in that case, you have to use a global keyword. If you remember, we have talked about global before. So I will say global I. Now you can access I inside the function as well. Let's run this, and okay, we got another error. It says, oh, I'm using plus. That's my bad, okay? So since I'm coming from Java background, so we have this habit of using plus there. So if I run this code, you can see we got it, and the last value for I is 91996, but it is going, so the limit is 2000, it is stopping at 1996. So that's awesome, right? So this is how you do recursion. You can call itself. But does it make any sense? Think about this, you are doing it for fun here, and that perfectly makes sense. So when you work on a project, do we really use recursion? And the answer is yes. Okay, so a lot of projects we do use recursion because recursion gives you something which you can do without recursion, but then it makes much more sense to use recursion there. In fact, in the next example, we'll be doing factorial with recursion, and that will be fun. Okay, I will try to do something amazing so that you will understand how to do factorial using recursion. So I hope this makes sense. So recursion basically means a function calling itself. Okay, that's what we have done here. Now till this point, we have talked about functions, we have talked about recursion, and we have also talked about factorial. Now in this video, let's combine everything and let's find a factorial of a number with the help of recursion. Now just to recap, what is recursion? It's a function calling itself. So let's say if you have a function a, and if a function calls itself, that's a recursion, right? In fact, we have done that with the help of read function, and then we try to print hello, right? So let's find a factorial here. Now when you say you want to find a factorial, it's very simple. You will say you will take a result variable, and in that you will be storing a factorial of a number. Time being, let's find a factorial of 5. Maybe you can take the input from the user, that's your choice. And now let's print the, oh, not print. Let's print the value of result. Okay, that's what we want to do. But then we don't have this function fact, right? Let's define it. So the way you define a function is by saying def, and then you mention a function name, right? So we'll say fact. Now this fact will take a variable, okay? It will accept a variable, so I will say n, and in this n you will pass a value. So time when we are passing 5, right? Now the thing is, we need to return the value of factorial. Now we know one way of doing it, okay? We have done that before. We have used a for loop, right? So we can start from 1 and we can reach to that point, and then we can multiply the numbers as we have done that. Example for this, it will be 1 into 2 into 3 into 4 into 5, right? But in this case, this is not what we want to do. So let's imagine I am fact function, okay? So you are the user and you are saying, hey, hey fact, give me a factorial of 5. So you're talking to me, okay? So I will say, okay, my job is to give you the factorial of 5. So that means I have to say 5 into 4 into 3. Oh, hold on. For that, I have to use a for loop, right? What I will do is I will say, okay, 5 into 4 factorial, because if I can find that, I will give you the value, right? But unfortunately, we still have to find 4 factorial. So what I will do is I will say, so I will take a help of someone. I will say, hey fact, oh, I'm calling myself there. Hey fact, can you give me a factorial of 4? Okay, because, so you are asking factorial of 5, right? I'm asking factorial for 4. So I'm calling myself. So I'll say, hey, can you give me a factorial of 4? Oh, factorial of 4, right? It's very simple. So what I can do is I can say 4 into 3 factorial, but I don't know how to find a factorial of 3. So I need help here. Hey, can you give me 3 factorial? Okay, I always do that. So I will say 3 into, so my job is to find 3 into 2 factorial. I don't know what this 2 factorial is. Hey, can you help me with that? Oh, 2 factorial, right? So it's very simple. It's 2 into 1 factorial. Oh, but I don't know what is 1 factorial. Hey, can you help me with that? Oh, hold on. 1 factorial is, oh, for that I have to say 1 into 0 factorial, right? Because we're following the pattern here. Okay, so for that I have to say, oh, I don't know what 0 factorial is. Hey, can you help me with that? Of course, 0 factorial, it's 1. Everyone knows that. It's 1. So 1 into 1 is 1. Okay. 2 into 1 is 2. Oh, 3 into 2 is 6. Okay. 4 into 6 is 24. Okay, so now we got 4 factorial, which is 24, right? So now my answer is 5 into 24, which is 120. So you got the answer. So if you can see, we got a factorial of 5 and I'm calling myself, right? So there's no for loop here. I'm calling the same function name. So this is called as recursion and you got the answer, right? So let's implement the same concept here now. So what I will do is I'm calling myself, right? But if you can observe here, what I'm doing is I'm simply saying, I want to return the value by saying 5 into 4 factorial. But hold on, we cannot simply use a number here, right? So 5 is n, right? So I will say n into, but I have to also find the factorial of 4, right? So I will say fact of. Now when you say you want to find 5 into 4 factorial, later you will say 4 into 3 factorial. That means it is always 1 less than the n, right? So you will say n minus 1, right? So I have to find n into a fact of n minus 1. But we have an issue here because we are calling itself, right? So there should be some limit. In that case, what you will do is you will first check if the number is 0, because if you remember, the top one is, so the moment you say 0, if n is equal to 0, in that case you will simply return 1, because we all know the factorial of 0 is 1, right? So this is how you do it. So it's so simple, right? There's not a lot of code here. And let's run this code and you can see we got the output, which is 120. So that's how you find a factorial of a number. Now till this point we have talked about functions, right? And how do we define functions is by using def keyword, and then we mention the function name as well, right? What if I don't mention the function name? Can I do that? If I don't mention a name, it becomes anonymous, right? And that's where we can create a function in Python called as anonymous functions. Functions without name, or you can also call them as lambdas, okay? So let's see what that mean is. So what I will do is, let's say if I want to create a function, normally what we do is we say def, and if let's say if I want to find a square of a number, so what we do is we say square, and we pass some parameters. Let's say if I pass a, and on this a, I want to perform an operation which is a into a. And then the way you call them is by saying, if you say result is equal to square, you call that function, right? And you pass a number. So let me pass number 5. I want to find a square of number 5. And in this case, I also want to print the value for result. Now, of course, this will work, right? We have done that before. It works. You get 25. But look at the code now. So we have this function definition, right? So normally when you talk about functions, we expect it will have at least 3 to 4 lines of code, or maybe 5 lines of code, right? Look at this, it only has 1 line of code. What it's doing is it is returning that value, right? So we have only one expression which is returning a value, that's it. We are wasting 2 lines with a def keyword, with a return keyword, with a name of function, right? So what if you want to use a function only once and you don't want to define the name of the function, right? And if you only have one expression, can we do that? When we talked about function, there is one thing about functions. We can pass functions to a function, okay? So that means the way you pass values, the way you pass objects, you can also pass functions, because functions are object in Python. If you talk about this square, now look at this code, it perfectly works, right? But the only problem which I have here is, I will not be using the square function multiple times. I will be using that square function only once, and that too, it has only one expression. So instead of defining a function, we can define a function when you want to use it directly, okay? You can simply say a colon, this is your function arguments, okay? So you have to say a, that's your arguments, the arguments which you're passing, and the operation on that argument, which is a into a, right? So we got this function, which is anonymous, okay, which accepts a value a, and what you return is a into a because you want to find a square of it. But the thing is, you need to use one more keyword here, which is lambda, because the anonymous function, they are also called as lambda expressions, or you can say lambda functions or lambda expression, you can say whatever you want. And then if you want to use that lambda, okay, the thing is, as we mentioned, that functions are objects in Python, so of course you need to assign it to someone. So you will say f equal to lambda. Now this f represents your function, okay, and you can pass that function to any function. You can, in fact, we'll be seeing that later. So we can use this function in other functions as well. We will see that. Now what I want to do is I want to find a square of 5. So look at this, we are simply saying lambda a colon a into a, and that assigned to f. Now since this is a function, we have to use a bracket, right? So whatever you pass here in 5 goes to a. We will perform some operation on that a, and then you will get it back. Now I know at this point it looks a bit weird, but hold on. Once we talk about, some other functions available, how can we use lambda functions in other functions, it will be awesome, okay? But time being, this is how it works, okay? So if I run this code, you can see we got the output which is 25. Let's say if you want to define a function which will add two numbers, okay, we can do that. Let's say if I pass 5, 6, okay, so we are calling a function f which doesn't have a name, okay, and we are saying 5, 6, and then that value will go into two variables, right? So I will say a and b, and I want to perform the operation, right? So you will say a plus b. So point to remember, you can pass any number of arguments, but it should be only of one expression, which is in this case a plus b or a into a, something like that. It should be one expression. So that's your anonymous functions, okay? So we are defining a function with the help of lambda, and it doesn't have a name. Now, in the last video, we have talked about lambdas, right? We have talked about anonymous functions. We are still not confirmed where you will use it. Of course, we know the concept that we have a function without name. It should have only one expression. It can take multiple arguments. But hold on, where you will use it? So in this video, we will use 3 functions. One is filter, map, and reduce, okay? And let's try to use this lambda there, and you will understand the importance of it. So to understand this, what I will do is I will take an example here. The example is, let's say if I have a list of values, I will say nums, and in this nums I have certain values. Let me just drop those values here. So we got these values here, okay? I don't know how many numbers are even or odd. Of course we can do some complex example here, but just to make it simple, just to keep it simple, let's go with this. So we got this number. I just want to check how many numbers are even. In fact, I want to fetch all the even numbers from this list. So I want to get a new list which is evens, and in this evens, okay, I don't know if it is a good name, evens, but it doesn't matter. So in this evens, I want to assign all the even numbers, okay? How will you do that? Of course, you have to write a function, right? And then we have an inbuilt function in Python called as filter, okay? So we have these functions. So what this filter will do is it will take the list from you, and it will filter those lists. It will give you the values. So you will say, hey, I want even numbers. Filter will say, okay, done, okay? So filter will take the sequence, and it will give you a sequence, but we want a list in return, right? So this filter will give you something. I want a list out of it, and that should work. But there's one problem here. When you say filter, how would filter know what values you want? Because see, we will pass nums. That's perfectly right. That's perfect. We will pass nums to a filter. That's a sequence, right? That's a list. But then how it will return? So what should be the condition, right? And that's why filter says, hey, you give me function. If I say control space here for filter, so filter takes 2 arguments. The first one is function, and second one is iterable, which is sequence in this case. But what function we are talking about? So what we do is we have to say is even function. So we are passing is even, but is it an inbuilt function? Of course not. So that means we need to define this function. So I will say def. I will define this function is even. I just went with this name because I'm not able to record any name here. And this is even takes a value, let's say the value is a or n, and this will return true or false. If that n is even number, it will return true. If that n is odd number, it will return false. Example, let's say if I give you a list of phones, and some phones are Android phones and some phones are non-Android phones, maybe Windows Phone, iOS, or BlackBerry. So if I give you those phones, your job is to filter it, okay? So I will say, hey, filter based on Android, non-Android. So you will take the phone and you will say, okay, this is Android, keep it here. This is not Android, keep it there. So this is what we are doing. So in filter, this is what it does. So if it is true or false, depend upon true, it will give you the value. If it is false, it will not give you the value. So we'll say return I mod 2 is equal to 0, okay? So if it is not I, n, how can I say I? So I will say n mod 2 is equal to 0, that's it. Okay, so this function returns a value, true or false, based on this expression, right? And this should work now, because if I print this evens, see the output. It gives you all the even numbers. So in the list, you do have odd numbers, or unfortunately, we have only 2 odd numbers, but that's fine, okay? So in the even numbers, you can see in evens, we only have even numbers now. So this thing filter takes 2 arguments. The first one is the function, where you will mention the logic, and second one is the list or the sequence. But don't you think this function here is only to be used here, right? See, normally when you talk about functions, we use functions so that it can be reusable. But look at this function. Don't you think this is a very customized function only for that purpose? And it only returns one value. So in that case, you can use Lambda. So you want to know how to use Lambda here? It's very simple. We don't need this function, because in this function we need only 2 things, the variable name n and the expression, right? So I don't want this. In this, so instead of using is even, we'll mention the function here itself. So you have to say Lambda space, mention the variable name, which is n, or any variable name for that matter, give a colon and mention the operation, which is n mod 2 is equal to 0. That's this. You are defining a function. So you're saying, so this is my sequence, which is list in this case, and this is my function. Based on that, filter it, and it works, okay? So that's the beauty about Lambda. So you can reduce the number of lines you are using, and it makes your code look cool, right? So that's what programmers do, right? Making things cool. Now let's try with map. So let's say we got all the even numbers, right? So in this, we got all the even numbers. Now my job is to double all the values. So whatever even numbers you got, I want to double it. Or maybe I want to say to +2. So whatever even numbers we have, I want to say +2. So even numbers are 2, 6, 8. I want to say +2. So 2 should be 4, 6 should be 8, 8 should be 10. So that's what I want to do. Now whenever you want to change every value, we can use very simple concept called as map. Okay, now I don't know if you have ever heard about big data concepts, right? So when I was learning big data for the first time, was when I was doing something with Google's MapReduce concept. This is what we do, you know. So we take the chunk of data, and then we try to filter that data, and then we map it, and then we try to reduce it, okay? So this same concept can be implemented here. So if you have a bunch of values, filter out the values which you don't need, and then apply some operation with the help of map. So what map does is it takes the value, apply some operation, maybe +2, multiply, depending upon what you want. And then you can also use reduce function, which we'll see later. So if I give you a chunk of data, let's say if you want to add all the values, reduce. If you want to multiply all the values, reduce. If you want to find one value out of the chunk, you will use reduce. It can be sum, it can be any other logic. Or maybe average, right? So here what I want to do is I want to double all the values. I would say doubles, right? So we got evens, and then we want to find doubles of it. So of course I want in the list format, and this time I don't want to filter it. I want to map. I want to change all the values. So I will say map, and in this I will pass evens. But then when you say map evens, you have to also pass one more thing, because map takes 2 arguments. So map takes a function and iterable, again the same problem, function. Now what function I'm talking about is the logic, right? So we can do that here. We can define a function. We will say update, because it's updating the value. It will take n, and what you do is you have to just add 2, right? So you will say return n plus 2. So whatever value you are getting, you will simply say n plus 2, right? But and then we have to pass that update function here, right? So map takes 2 arguments, the function and the sequence, right? We are doing that here. But there's only one thing, right? I don't want to use this function, because the only purpose of this function is to work with map, right? We will not be using this function anymore. So in that case, instead of doing that there, here itself we can say Lambda, as we did before. We can say Lambda n colon n plus 2, right? It's so simple. You can simply create an anonymous function or Lambda here itself, right? So this works, we got double. And the last one is I want to perform reduce. I want to reduce all the values. Example, if I print this double first, let me just print doubles. So in this doubles, you will get the same stuff, but then you are saying +2. Oh, we were supposed to do double, right? So I have to say into 2, not +2. In fact, your logic, right? So you want to double it, or you want to say +2. But since that by mistake I've taken the name double, so I will make it double. Let's run this, and you can see we got 4, 12, 16, 8, 12, and 4. That perfectly works. But now what I want to do is I want to reduce the value. So instead of having multiple values, I want only one value. I want to add all these values, right? Now technically when you add values, how we do it is you simply say, okay, 4 plus 12 is 16, 16 plus 16 is 32, 32 plus 8 is 40, 40 plus 12 is, I mean, list goes on, right? So you, at one time, you only add 2 values. Even if I give you 10 values, you will add 2 values at a time. That's important. So how will you do it? And that's where we will use reduce. So I will say sum is equal to, of course I'm not expecting multiple values here, I'm expecting only one value, that's why I will not be using list. So I will use a function called as reduce. But the problem is that you can see it says no suggestion, that means we are not able to use reduce. The thing is, this reduce function, it belongs to a module called as function tools or func tool. So I will say from func tools import reduce, because we want to work with reduce, right? And then we can say, now we can perform this operation, so we can say reduce, and now reduce, if I say control space, oh, reduce also takes 2 things, okay? The thing is, we have to pass 2 things, right? The first one is the function, okay, the logic, of course, because it depends upon what you want to do. Maybe you want to add all the numbers, maybe you want to multiply all the numbers. So you have to pass a function, and then you want to pass a sequence. So sequence is there in doubles, because I want to add all the values of doubles. But I also need to specify, okay, what I did, I just made a mistake there. Okay, and then this you have to pass a function. Now what function I'm talking about? So what I will do is, here I will create a function which is def, and I will call this function as add all. Of course you can use any function name. And this will take 2 parameters, okay? So when you say a function for reduce, it will always take two values at a time. So I will say a comma b, and here with those 2 values, see, it doesn't matter what you want to do, you always take 2 values at a time, so you will say a plus b. Depending upon what logic you write here, it will do that. And here, you have to pass add all. Okay, that's what you do. So in reduce, you pass 2 parameters, function and sequence, and now, instead of printing double, I will print sum. Okay, we got an error. Okay, my bad. Okay, so I'm doing reduce inside reduce. My bad. What's wrong with me? Okay, you can see we got the output which is 56. Okay, you have to trust me at this point, it should be 56. So now let's use lambda here, right? So instead of doing this, let's use lambda. So in lambda, what you will do is, you will again, instead of using add all, you will say lambda. Now you need 2 parameters, right? You will say a comma b, and you will say a plus b. So it will take 2 values at a time. So when you say you have doubles, let me also print doubles here, because I want to show you how it will add those 2 values. And we don't need add all function now. Let's run this code, and you can see it is finding double of all this. It is adding all these values, right? At one time it will add 4 and 12, which is 16, and then that 16 will be added with another 16, right? And then it will be added with 8, and then 12, and then 4, right? That's the sequence it follows. So at one point it will take 2 values, and that's what reduce is doing. So that's how we work with filter, map, and reduce with the help of lambda. Okay, you can say lambda expression or lambda function, your choice. So I hope you understood something from this topic. Try it out, practice, because this is not that easy. Now till this point we have talked about functions, right? And then we have done so many stuff till now. We know how to add numbers, we know how to find factorial. But think about this. When you work on a project, of course you will be solving a real life problem, right? And that may be a complex project. Now when you say a complex project, it should be simple for the users, right? You should not build a complex project for a user. But then for a programmer, every project is a complex project, because you'll be writing a lot of code, right? Maybe 1,000 lines of code. Now this is where the problem starts, you know. See, we have a concept of debugging. Now when you say debug, it simply means removing bugs, right? What about coding then? If debugging is removing bugs, then coding is actually adding bugs, right? So every time you code, you add new bugs. Now, even if you don't do it intentionally, it happens, you know, because we are trying to solve a problem, and around that, you will be writing some code which will increase bugs. Okay, now how do you manage this stuff, right? Because if you increase bugs, of course, at some point you need to read your own code, you need to understand how to remove those bugs, and your software should be maintainable. When I wrote this code, only God and I understood what I did, and now only God knows, right? So it happens, you know, when you write a code, after some time even you will not understand what you have written, because when you have 1,000 lines of code, it's difficult to track. The second problem is, if you write everything on the same page, or everything at the same place, it is difficult to manage it, and if you change one point, it may affect other code as well. And that's where what you will do is, if you want to solve this problem, we will be using a concept of modules. So instead of writing one big software in one file, you will break it down into small parts, right? Example, let's say if you have A, B, C, D as a software, you want to build a software in which you have these 4 features, and that's a one project, right? It's a combined project. So what you will do is, even before starting the actual project, what you will do is you will break it down, the components on paper. So you will write, hey, we have A, B, C, D, now we have to break it down in logical parts, right? Of course, you cannot simply break down software, you have to think about it, you have to break it down in logical parts, right? So all the same features should belong to the same module. So you will say, okay, we have A, B, C, D, well, A and C can be one module and B and D can be one module. Okay, so that's what we have done. And then further you will realize, okay, we can actually also break it down A and C. So you have saying A module, C module, B module, and D module. So we are breaking things down. The advantage is you will be building 4 different modules, right? The first advantage would be if you want to change something in A, it will not affect other modules, right? Because they are separate now. It may if you are doing some tight coupling stuff there, but normally it doesn't affect. So when you write a code, if you change something in A, it will not affect other modules, or it may not affect other modules. The next thing is you can also reuse your modules. Example, let's say after this project, you are building a new project with some similar features. Example, now this time you are building maybe GADP. So we have this other project. Now here, you can actually use A and D module because you have already built it, right? So that's the advantage of using modules. Now, can we do that in a project? In fact, we'll not be building a complex project here. Let's do it simply. But then if we talk about a module, what it will have. So in Python, we have this concept of variables, we have functions, we have classes, right? Again, we'll be talking about classes later, but we have that concept. So in one module, you can have all the different stuff, right? So we can have variables, we can have functions, and we can have a class. Or you can imagine at this point, your one module will be one file. So the way we are doing a file here, we have demo.py. This is your one module, right? We can create another file as a separate module. Let me show you something. So let's say this is my main file, right? And here I want to add 2 numbers. So what normally we do is we simply say A is equal to 9 and you say B is equal to 7, and here you will add those 2 values, right? Maybe you want to perform all the operations, right? Addition, subtraction, deletion, multiplication. So you can do that here itself, or you can create functions. And now we know how to create functions, right? So we can do that here, but we can create modules, right? So you can create those 4 functions here in the same module, or you can create a separate module which will have all these functions. And that makes more sense, right? Having a separate module. So let's do that. So what I will do is to create a separate module, I will create a new file. So I will say new, and let's go to Python file. We'll name this as a calc because this calc will have all the functions which you need. So this is a separate module for you. And let's define the function. So we'll say def, and the function name would be add, which takes 2 parameters, which is A and B in this case, and we'll simply return A plus B. That's our first function. Likewise, we can create 4 functions. Let me do it quickly. So you can see now we have this module which is calc, which has 4 functions, right? We can see that here. Now I want to use this function in another module which is demo. How can I use that? So because if I simply type add, it will not work, right? You cannot simply call add it. Of course, it will not work directly. So even if I pass a comma b by saying c equal to add a comma b, it will not work because it is in separate module. So we have used some inbuilt modules till this point, right? So if you remember, we have worked with import, right? So we used to say import something, and then we have also used from a module import specific functions or the classes. We have done that, right? But we have done that for the inbuilt modules. How about our own module? Because calc is my own module now. So what I will do is, if you want to use calc, we need to import it. And the way you do that is by saying import calc. The job is done. You're saying import calc. And whenever you want to use it, you will simply say calc.add. So there's one way, right? You can use a module name and then say .add. Or if you don't want to say calc every time, because of course if you want to add, if you want to subtract, you will be using calc.subtract, calc.multiply multiple times. Instead of that, you can say from calc, import whatever you want to import. I can say import add. So in the one line you can say add, in the next line you can say import sub, import multi, or you can say import start, right? It will import all the functions for you. And now you don't need to call calc. It will simply say add, it will work. right? It's a beauty, right? So this is how you break down your project into small parts. And of course, it doesn't make sense to have a separate module for separate functions, right? So all your logical functions should work together in one module, not just function, classes, variables, whatever you want, right? And now once we got this, you can print the value of C, and it perfectly works. Let's run this. Okay, so you can see we got the output, which is 16, 1 and 6. So that's what we wanted, right? 9 plus 7 is 16. We can also do that for subtraction. Everything will work here, and you can see we got 2. So that's how you use modules. You can create multiple modules, not just 1 or 2. You can create 10 different files as different modules, and you can import them the way you want, right? In fact, in Python itself, we have different modules available. Now in this video, we are going to talk about a very special variable name as name. So it's a variable, special variable name. It's because we use a double underscore here. So in Python, we have this special concept called double underscore. Again, we'll talk about that later, but at this point, let's focus on name. Now, what is name? So let's say, if I go back here and if I say print, I want to print a name variable. So we can directly use double underscore and say name. And the moment you run this code, you can see we will be getting main. Now, what is main? Now, if you are coming from C, C++ or Java background, we know that, main is a starting point of execution. Same goes for Python. The moment you run this code, if this is your first code, okay, because see, in your project, you might have multiple modules, right? Maybe 5 module, 10 module, but there will be some module which you will run first. So this example demo.py is my first module. Maybe with this demo, I will be having multiple modules, right? So, but this is my first module. So the first module name is always main, because that is the point of execution. So that's where your code starts. So the value for name here is main, but here's a twist. What if I go back to calc, okay, so this is demo, right? The file which I'm working with now is demo. If I go back to calc, so you can see calc is empty. At this point, just to test, I will print hello, that's it. My main purpose here is to print hello, that's it. So if I run this one, you can see it says hello. Nothing else, just says hello. Now after hello, let me print the name variable here. So I will say name underscore underscore. Now what do you think? Will it print main or something else? Of course, since I'm running calc, it will print main because I'm running calc, right? But if I import a calc in demo, let me just do that. I will say import calc. Now what will happen is everything which is there in calc will come to this demo file, right? Including the print statement. So that's why if I run this code, of course, this will print name. Instead of just printing name, let me also print demo says. So I'm saying demo says name. So demo will print what? Of course, demo will print main. What about calc? Now calc will print the name of the module. So you can see it says hello calc, which means that's the name of the module. So if you are running calc, of course, this name will be main. But if you are importing calc in another module, then it will print the name of the module. Okay, that's important. So the moment you say name, it's very special, the value changes. That's why it's called variable, right? So name value changes as per the place where you're using it. So if you are running the file as a main code and if you're using name, that will print main. But if you print name, which is imported as a module, then it will print the module name. Now, why is helpful? It's because we have talked about functions, right? And we say that everything, so let me just remove this part as of now. So why it is helpful, why this name is helpful is because when you work on a project, of course, everything should be in a function, right? Example, even if you want to print hello, that's it. My main job here is to print hello, and then I want to welcome the user. So if I want to say print hello, and then I want to say welcome user. So I want to do these two things, okay? I want to say hello, I want to say welcome user. Now I want to do this only when this demo is the first file, okay? So I want to print hello and welcome user only when the demo is the first file. So if I run this code, you can see we got hello and welcome user. But the problem is if I go back to calc now, and calc is doing something, okay, calc will have its own statement. But here I'm also importing demo, and as I mentioned, calc will have its own feature. Let's say it's time to calculate. That's it. I just want to print in times to calculate. Now since calc is my first code here, okay, so I'm not running demo, I'm running calc. So demo becomes a module for me, a separate module. The moment I run this calc, it is also printing hello and welcome user. I don't want to do that. So to avoid that, what you can do is you can define this in a function. You will set def, and you will write the function name as anything. Maybe I will just time it, I will say main, and I will put these two statements inside main. So you can see I have written those two statements inside a main function. Okay, now of course you need to call it, right? So normally if you want to execute that from demo itself, you have to call them. So if I run demo now, and if I run this code, you can see it will print it. Okay, that's an issue. I want to call main only when this is my first code. So in this case, you can check if the name variable, remember the name variable, if the name variable is equal to main, right? Now see the magic. If I run this code, it will print hello and welcome user, but the moment I go back to calc here, and if I say run calc, this time I'm using demo as a module, and you can see it only prints in its time to calculate. So this is the idea, okay? So if you want to start a code, and if this is the first thing you want to show the user because this is the start of the code, and you want to call it, that's where you will use this thing. And that's why if you see Python codes or some books, this is what they write, okay? So it simply says if name is main, then only execute main. Otherwise, if you are importing this as a library, you don't want to print main. So that's it, everyone. That's how you use this special variable called as name. Now in that video, we have discussed about the importance of name and how do we use it with main. But again, it created some level of confusion, so let's clear it here. If you don't have any doubts in that particular video, you don't need to watch this video. You can simply skip it and watch the next video. In case if you're not feeling ease with that video, this is where I will try to remove your confusions. So to define that, let's go for another example here. So let's say I'm working on a project, and of course when you work on a project, you will be creating some module, right? So in this case, I have two different modules. We have demo and then we have calc. I'm now working only on demo, okay? I'm not focusing on calc as of now. Let's focus on demo here. Now inside demo, I want to accomplish some task, right? And the way you do that is by defining some functions. Now in this, I will define a function. Let's say I will say def, and this is fun1, okay? This is my first function. And in this function, I will do certain tasks. I will use some variables, I will assign some values to it, and then I'll perform some operation on that. And at the end, let me print from fun1. That's my first function. And let me define one more function here. The way you do that is by just coming down here and paste. And I will define this function name as fun2, and I will say this fun2. Okay, so imagine this function had a lot of statements. Now, if I try to execute this file, if I say run demo, of course you will not get any output because we are not calling them, right? So ultimately, when you define a function, you need to also call them. The way you do that is by saying fun1, and then you will say fun2. Okay, these are the two statements we are printing here. So it means on this code, and you can see we are getting fun1 and fun2. The twist is, normally when you define functions, normally when you work on a project, if this is your standalone application or standalone code, if this is the only file you are going to write in your project, normally what we do is we define everything in a function because statements should be a part of a function. So even this function calling should be done inside another function. We'll say this is def main. Now this is the standard procedure which we all follow, because if you're coming from other programming background, let's say C, C++, Java, we do that, okay? So main is a starting point of execution. So generally we define the function name as main. And of course main will not be calling itself, right? Example, if I say run demo, you can see we are not getting any output because of course you need to call main as well. So at the end you will call main and it will work. So you are calling one function main, and main will take care how to execute all the statements, and then you can call them, right? This is how generally we make a software, okay? So we have a main function. From the main function, you will call all other functions. So this perfectly makes sense. Let's go back to calc. Okay, now let's say I'm defining a calculator here, and then in the calculator as well, let me define some function. I will say def sum, and this function does something. Of course, it will add two numbers, and I will say result 1 is, okay, something like that. Okay, so I'm defining this function, and let me also define another function, which is, let's say, subtraction. Again, you can define this function fully if you want, but as of now, let me just keep it simple. So we'll say sum, and we have sub. In fact, it should be add, right? It makes more sense. So we have add and we have sub. Of course, to call this function as well, I need to say def, and in this def, I will say main. Of course, to call them, we need the main function. And from this main, I will call add, and from this main, I will call sub. And at the end, we have to call main as well. Otherwise, we cannot call them. So from this code, you can see we got result 1 is, result 2 is. So this is how we define files, right? So we got two different modules. We got demo and we got calc, and they are working perfectly. Now you want to use calc in this. So when I say function1 want to use add. So when I say from fun, I also want to call add function from here. So let's say I want to reuse the code, right? So I want to reuse this add function function in this demo. That's what we do. That's why we define functions. Now, in order to use that function, what we have to do is we have to say import calc, or maybe you can say from calc import add. So now we are importing that particular function, which is add, right? And you can see we are writing add here. So will this work? Of course, let's try. Let's run this demo. So I'm not running calc now, I'm running demo, right? So the output which I'm expecting is from 1 and from 2. And of course, we are calling add. So it should print result 1, right? This is what I'm expecting. I'm not expecting result 2 because I'm not running calc, I'm running demo. And in demo, we are not using result 2. The moment I run this demo, can you see that? We are also getting result 2 and we are getting result 1 as well. This is weird, right? We don't want this. The reason we are using this demo is we want to print from 1, we want to print from function 2, and we also want to print result 1 because we are calling it. We are not calling substrate, it is printing result 2. It's because the moment you import a library, the moment you import a module, it will execute all the statements, and in that you can see we have main. It is calling main, right? And main calls all the functions. We don't want that, right? So we have to say, hey, I want to call main only when I'm executing this particular file as a standalone program. So I want to call main only when I call this as a standalone program. I don't want to call main when I'm running it from another file. So here I'm just concerned about add. I'm not concerned about main. So in that case, because if I print a statement here, I will say in calc main, and if I go back to demo, so I'm not calling main from here, and you can see it still says in calc main. Why you need to call a main of calc? That's the question, right? Because we are running demo. This is my first code. I'm using calc as a module. In that case, what you will do is you will call main only when I'm running calc as a code. So you will say if. Now, how do you know that this is the code I'm running? So whenever you run a code and whenever you execute a code, there is a variable called as name, which will hold the name. So if this is the code which I'm running at the start, the name variable will have main as a value. So let me repeat, if this is the file which I'm running, this name variable will have main as a value. Otherwise, this name variable will have the module name. Example, let me print inside add, let me also print, I will say result 1 is, and let me print the name variable. Let's see what happens. So I'm printing a name variable, okay? Let me go back to, let me just run this calc first. I will say right click and run. You can see it says result 1 is main, okay? So that means this code is running itself, right? This is your standalone code. The moment you use calc as a module in some other code, and now if you run this, you can see it says run result 1 is calc, okay? It's because the name now is printing the module name. So that's important. That's the importance of this name. And you can also see when you run this code, we are not getting result 2 because now you are saying if the name is main, then only call main. Otherwise, other code will use this as a module. I hope you are getting my point here. So I tried my best here. So let me know in the comment section if you still have any questions. I will try to, maybe because in other code in future videos, we'll be using this a lot. Maybe it will clear your confusion there itself. So that's it, everyone. I hope you're enjoying this. Let me know in the comment section. That's it. Bye-bye.